Okay.
Yeah.
So, good afternoon, all. First of all, I would like to extend a warm welcome to Mr. Vivek Devangan, whom we know for a long time, and we at ICC have been fortunate enough to work closely with him in his various roles. So, thank you for sparing time and being with us. But we at ICC and personally we are quite happy to see you here. We have some eminent experts with us from the switchgear sector, and they'll be sharing their thoughts, views. But just to set the background and just to set the tone, I don't think I need to talk about the technical things. For that, we have the experts. But broadly, just to emphasize what role switchgear has to play, and also with the growth which India is seeing after, I would say, third wave of COVID, economy is rebounding. And in the last 2 years, government has made significant steps to push for Make in India. I think there is a push not only from the PSUs, various government bodies, but all the policies are also oriented toward promotion of Make in India, and also the review of the custom tariffs. I think again the idea is to push manufacturing in India and also to encourage, let's say, the large buyers from India to buy from Indian companies. Switchgear industry growth is linked with the growth of industry and infrastructure. There are newer technological developments which are happening. I'm told the gas insulated switchgears, they are expected to dominate the market going ahead. Similarly, they have a large role to play in the entire distribution network. And just to set uh, the tone and also to, let's say, have a set of issues and ideas, Mr. Devangan has kindly agreed that we take few remarks from the sector experts, and that would form the basis for us to discuss, and also for Mr. Devangan to respond to some of those.
Correct.
So with that background, may I welcome everybody, all our experts, once again, and may I first request Mr. Rajeshi Ghosh, if you could share your thoughts. And the thoughts are basically how you see the sector, what role government can play, technologically, if there are things, if there are some barriers where government can intervene, and how this sector can achieve the growth in terms of manufacturing and also in terms of exports. So idea is to generate the issues, also some of the ideas which can be more positive and growth oriented. So feel free to share your thoughts. Over to Mr. Ghosh.
Thank you, Mr. Singh. Mr. Afternoon, Mr. Rajput, Mr. Devangan, and all other speakers. So actually, I am from CSC Kolkata, which is a century-old utility, which actually introduced commercial power to this South Asia itself. And 17th April 1899, the first generation plant in Kolkata has been set up. So during this entire century and almost 125 years, we have a long journey, and CSC always tried to be ahead with both its processes and the technology. So presently, if I tell about what is our recent problems and today's regulated and competitive environment, what problems we are facing regarding the switchgear industry and how it can be made better. So I can tell few of our issues which need to be addressed by the manufacturers as well as by the government bodies by creating some regulations or like that. So number one, I can tell that faster obsolescence of the product. It is an issue for the utilities, majorly because the utilities have to ensure better utilization of the capex, that means the assets, through its extension of plant life. As much as it can be extended without compromising with reliability, it should go with the assets. But so that the customer get the maximum benefit from this. But in many cases, what is happening, the manufacturers change their products due to upgradation or due to their internal policies. And what we are suffering because of that, because say switchgear we have procured in 2015, now the manufacturer is telling that the product is discontinued. So we are asking for the spare support. They are telling that the spare support can be given for 5 more years or maximum like that. You have to procure some spares immediately so that you can continue with your product. Otherwise, in future, they cannot give the support. So what we need, number one, discontinuation or modification of a product, these should be done with a detailed discussion of its customers. That means who are using these products, a detailed discussion should be there before any type of modification or change of product. And if at all it is discontinued or modified in agreement with the customers, the spare support should continue at least for 10 more years. Otherwise, the product, the costly products which we are procuring, we have to maintain it. Otherwise, it is difficult. A few months back only, such an incident happened when we have told from the manufacturer that we have to buy a spares amounting, we have more than 400 such panels which are there telling that it will discontinue, and we have to buy spares of costing more than 4 crores. So it is not a in between a financial year, and now every utility is going very tight. So it is very difficult to adjust all this cost and everything. So this is so the product obsolescence and the spare support. This is a major issue. Regarding the modern switchgear, modern technology, we have the IoT sensors, all these remote monitoring facilities, which is not very, I will tell in India it is in nascent stage, but still, since we have started using all these things, we also should support or should bring some regulations or like that, so that all these type of sensors, which is presently mostly imported and exorbitant costly, so these sensors can be manufactured in India by this Make in India movement. And all these should be standardized. It should be reliable product, low cost. So all these things should be promoted from the government side also. And also another part is the analytics part. After we get all this data from the sensors, we have to analyze all this data for which software is required. Nowadays what is happening, every vendor is coming with their own software. So their own software, their own sensor, that is compatible. If I go for another vendor, then the software changes, the sensor changes, everything changes. So there is a need for standardization or open platform software which can be compatible with different types of sensors. This is also a requirement from the utilities point of view. And lastly, regarding this sustainability, since it is sustainability is a very important issue in nowadays, all these GIS, all these modern switchboards, maximum are coming with SF6 gas. So this SF6 gas also need to be substituted by some environment friendly gas, but that also should come from different manufacturers. They are manufacturing different types of gas, coming with different types of gas, and it is difficult for an utility to replace the one SF6 with many types of gas. It is very difficult to handle such things. So if these things need to be addressed with some not only with the government bodies but also with the manufacturers, the utilities, everyone should sit together and resolve these issues, because the power demand is increasing and we have to make our systems reliable. We have to use the switchgear, and the switchgear industry must flourish inside India at least, so that we can get benefited from that. Thank you.
Thank you, Mr. Ghosh. May I now request Mr. Partha Pratim Ghosh, who represents MV Switchgear, to please share his thoughts.
Yeah, I will just, as a takeaway from Mr. Rajeshi Ghosh, he has highlighted a very important aspect. Am I audible?
Yes, yes, please go ahead.
Yeah. In fact, he has highlighted very important aspect of our country, rather the scenario switchgear, particularly at utility end, about the obsolescence of products. That is very, very important. And very much related to it is the proper site maintenance, which is not proper, unfortunately, in India. For example, earth pit is not maintained properly in maximum utility. Rather, whenever I visited a lot of substations, the earthing pit, which is very, very important for proper substation performance, it is not maintained at all. And because of this, there are substantial failure of relays, and today the relays are ID relays, part and parcel of smart grid, and that relays are also, failure rate of relays are also very high. That is one aspect I would like to highlight. Second, a very important factor is the specification, tender specification across the utilities that have to undergo a fresh look, because there has to be a thorough analysis of a particular substations through fault analysis, rather, to determine the actual fault level. In some specification, the fault level is overrated, and based on that, if a wrong breaker is selected, that will not give its proper life, because the TRV, if high fault current, in fact fault rated, short circuit rated breaker is supplied, rather, that will face a very high TRV and the breaker failure rate will be very high. So that is one aspect, rather, I would like to highlight. Rather, there has to be a proper body, and there has to be a fresh look on the tender specification, because age old tender specification that is going on, that we have seen time to time when participating in tenders with various companies. And another aspect I would like to highlight, rather, Mr. Ghosh also highlighted on that, that is the substation operational cost that becomes very high because of equipment failure. Now today, philosophically, the whole world is shifting from reactive maintenance to preventive maintenance. Today, by and large, rather, we are addressing equipment through reactive service. There is a failure, people go to the site, they rectify. That is the 99% cases, rather, we are following this route. Through smart grid, rather, we have to reverse the direction. Everything has to be preventive, because the one very important aspect of smart grid and smart switchgear, I will highlight during my presentation in more detail, is to have preemptive signals that there are some problems going to happen in future in the equipment, which will lead to failure in future. It has not failed immediately, but it is going to fail very soon. So this kind of data, communication and collation of data through proper analysis of data, there will be a signal back to the manufacturer and the substation officials, rather, there is a need to replace certain parts, spares, rather, as a preventive measure before the final failure. That is very, very important. Today, in fact, NSGM, it has formed almost in 2015. It is in operation from 2016. But till, rather, the implementation rate of a smart grid, I think it has to increase. 12 pilot projects so far it is in implementation, under implementation, and 4 are in progress across the India. So total 14 projects are there. Compared to the total number of utility in India, it is 76 utilities, considering the GENCO, rather. So there is a huge task. We have to speed up the implementation of a smart grid, which will reduce the cost, the equipment cost, as well as the substation cost. It will enhance the performance of the equipment also.
Sure. Thank you.
Yeah, thank you.
We now go to Mr. Saurabh Banerjee, who represents Pascal Switchgear, to please share his thoughts.
Yeah, good afternoon, everyone. And thank you for giving us this opportunity to be a part of this discussion. We are a very new company of maybe around 10 years now. And rather, to be very specific, that 7 years we are into this field where we are getting all the approvals and we are supplying the switchgear, medium voltage switchgear panels. So this is very new to us, and definitely being a part of all this community, it is a real helpful for us to know and develop our product range and service. So that way, I will thank the team and ICC to be allowing us to be part of this. Regarding the concerns and questions, I think Mr. Ghosh and Mr. Parthapratim has really highlighted very important issues that everyone is facing the challenges today. To add to these of the 2-3 points I have also mentioned, that we will be requiring support as a manufacturer from the utility as well as from the government side on the specification and on the liquidity issue. Because if you see today, the payment cycle and the amount as an MSME, the money what we require to produce and to deliver, that should be liquidified in the organization so that we can deliver on time and with the right specification. So that way we see that today whatever has been committed from the government organizations, from the utilities, we are facing a big challenge of the time frame. Whatever is committed, that is not maintained, and this is impacting hugely on the entire cycle. Secondly, I want to mention one point that being an MSME, we are finding a lot of challenge to get approvals and to be the lead bidder in any of the high technology projects. So there, if any kind of regulations or policies can be done, where being a company in India, we can collaborate and we can be the lead bidder in this type of tenders, where this high technology can be implemented and it can be a part of the switchgear industry. Thirdly, what I wanted to mention is being an Eastern region, we are facing a big challenge of getting a proper testing laboratory. There is no testing laboratory which is available in Eastern region. We have to ship everything to either in CPRI Bhopal or in Bangalore or in west side Ereda. So in eastern side, we do not have any kind of lab where we can do some R&D. We can do our product testing on regular basis. So if government can put some highlight and do some initiative to make some investment here to set up some basic labs like STC and temperature and impulse, which are the basic tests which is required for a medium voltage switchgear, that will be really helpful for us. Thank you. These 3 points what I wanted to mention.
Sure. Thank you. Thank you. May I now request Mr. A.K. Rajput, representing Central Electricity Board, please share his thoughts.
नमस्कार सर, नमस्कार देवांगन सर, नमस्कार सभी को. Myself, brief introduction. A.K. Rajput. I am Chief Engineer Research and Development, as well as looking after Make in India portion of the assignment with Central Electricity Authority, New Delhi. So I am glad to be among you, and it's my privilege that I have been invited at this forum. ICC also in few respects, and in dissemination of the knowledge whatsoever has come been obtained in the previous occasions also, and that whatsoever knowledge we got, we have applied in our working and we have disseminated with our colleagues and the professionals. So my view as related to this particular topic and the initial remarks, of course I will be making a presentation when my turn comes. Basically, when the switchgear, because other things have been covered, I will not be repeating those. What I feel are the new and has to be looked after by each and every professional in the field, particularly in the field. From the field point of view, lot of risks are associated with the switchgear installations. When they are silent, when they are not working, everything seems to be very fine. But when a fault occurs, there have been chances, and the reported, and I have seen by myself, that particularly in the minimum oil circuit breaker of 6.6 kV, the kiosk type, the bottle of the oil containing oil that breaks, particularly during the earth fault conditions. When the earth fault conditions occur, so this fault conditions takes place, the switchgear while opening, the problem was opening, and this particular problem was identified based on the experience and the data reported by all the professionals there. Those were the technicians and the foremen, and this was rectified, and that was at quite long back, 88, 89, in Badarpur thermal power plants, and afterwards the same switchgear, the same trolley worked nicely after replacement and the design modifications in the arcing bottles. So good housekeeping is a must, because if the good housekeeping is not there, whosoever goes there to supervise and to maintain, he may stuck up. And also there are reported cases which have turned out to be fatal also, because of the no fault of us and no fault of the victim. But these things also to happen. So I will insist that good housekeeping is a must. And unwanted pupil, or sometimes the stray animals and the stray dogs also enter to the switchgear part, switchgear installations, and they take rest there. So they also are the cause of the trouble. Another thing is, I will insist on the timely maintenance. You observe something, you have a log of your switchgear, how much current is flowing, for how much it is rated, what is the life of the switchgear, and how, say, while during the carrying out the preventive maintenance, you see how the contacts are behaving, whether the contacts are facing some chattering problem or others. So naturally it has to be derated, and those precautions need to be taken. And one more thing, at the time of the installation, at the location of the installations, there should not be some vibratory machines, the vibration of which passes on to the circuit breaker. So that is quite harmful. In the long run, it lead to the failure. So vibration is one thing, and another thing is, by good housekeeping, I mean that sometimes the sanitary water, the water from the washrooms and the others passes and comes directly on the panels, and the bus bars get sorted. Similarly, OEM also decide, and always in the specification you will find a phrase that the panel should be should protect from the dust as well as from the anti-vermin and the reptiles, those things. So cable glands should be properly sealed, otherwise the rats are the real problem, and they are the faults do not occur which are of the mechanical or electrical regions. Fault occurs particularly in the indoor switch gears because of the rats and the reptiles. So that is a common phenomena which is observed. So maintenance people have tough time in tackling these type of the problems, but careful maintenance and proper sealing and proper alignment of the things can overcome these type of the challenges. Then there is a need of the diagnosis of the failure and carrying out a detailed failure analysis. Maybe your design wing or the corporate operation services departments, they may be involved. That we did in our case, which I cited once. Then arrangement of spares, it's really a problem. Say your machines are open, people are waiting, and the operational, say if it is a generating machine, the operating staff, their machine is ready, but you are not able to provide them the auxiliary supply because of the failure of your main incomer. And that incomer particularly, you are held up because that you don't have few washers, because these are silent and they are hidden. They never come to, because they are not consumables. So they do not come to the notice. So a proper arrangement by an experienced person has to be made, and inventory has to be collected in advance. So sometimes it happens that you don't have these spares, but people know how to arrange them in urgency and all those things. Even sometimes one has to fly. Those were the days that one has to fly from here to say Bangalore and bring back the spares when the flights were not too frequent. Those are the cases. Then life assessment of the whatsoever asset is there. Either it is connecting cable with the switchgear, with the circuit breaker, or whether it is the control cabling. And if the control cabling has a lot of jumbling, then this is a cause of the trouble. One day it will invite problem. In the new type of the software, which are IoT based and are the SCADA compatible, in there you particularly need the cyber security aspects. That is the added feature, and one has to be very serious in making how the cyber security aspects can be taken care of. And one more thing which is missing, sometimes it do happen, the relay and circuit breaker testing equipments are not there. And if the equipment are there, they are not up to the mark. They are not maintained properly. They are not calibrated properly. So relay testing at site should be done either as per the OEM recommendations, or when some fault takes place and you get an opportunity to touch your relays and open your relays. So availability of the consumables is one thing. It is particularly more important in case of the oil type of the circuit breakers and now the Sf6 gas based circuit breaker. Similar is the case with the vacuum chambers bottles as a spare. The vacuum chambers bottles should be available in spare in sufficient quantity whenever a chance arises. Then a register we maintain for installation and historical defects. These all historical defects and its history should be maintained in the electronic register, so that we can assess that how is the performance and when there is a time likely to come to replace this particular equipment, so that inventory management and spare parts management could be done in a scientific way. A few more points I will tell and then I will quit. Then future needs to be documented and future projections, so that the budgetary provisions could be made in time, and because of the financial constraints, the assets do not suffer and the power supply do not suffer. Then one more phenomena is increasing fault levels are there. As the system grows, the fault levels increase, and this is basically a real cause of changing the existing switch gears with the higher capacity switch gear. Switch gears are generally designed to based on the pure sinusoidal basis. They are not taking into consideration whether the harmonic currents will be present or not. And if the harmonics are present, unnecessary heating will also take place. Similarly, the capacitors are not originally placed in the system. Capacitors comes at a later date. So when the capacitors comes or the cables comes, so capacitive switching and the cable switching, these are the quite onerous duty on the circuit breakers, and the circuit breakers should be specifically ordered for performing the capacitive duty. Then fault recording and deployment of the maintenance crew in time. This requires special attention, particularly in the distribution system. The maintenance crew is here and there, widely spread at different locations and engaged. So Wi-Fi based system, now the mobiles are also there, and some other scientific tools should be there, so that the crew could be located, and through GPS based vehicles, the location of the crew could be traced, and the expected time of reaching the crew to the maintenance site, to the faulty site, can be assessed. And then comes the issue of the main and backup type of the protection schemes. So because switchgear is not only the circuit breaker, it is basically the control, measurement and the relay part. So main and backup system protection schemes would be scientifically designed as per the OEM recommendations and the standard practices. Then bus bar arrangements plays a vital role in selection of the switch gears, whether we are going to have the double bus bar scheme or we are going to have the breaker and a half scheme, like that. Then testing facilities, as my previous speaker mentioned, the testing facilities need to be provided at convenient places, because long distance transportation, and that may take long time also, because the testing piece of equipment, which equipment under test, UTE we call, equipment under test, may have to wait for its turn to come. And similarly, if some type of the switchgear or some our components are like this, that they have to be transported in a special type of the vehicles. So those vehicles should be specially ordered and specially built. That's all for the time being. Thank you, sir.
Thank you. Thank you. We will take the last comment from Mr. Anjan Banerjee, representing GET&D.
Very good afternoon to respected speakers and Honorable Additional Secretary of Power. I am Anjan Banerjee from GET&D India Limited. As we are aware, GET&D Limited is present in our country for more than 100 years, offering products and services in transmission and distribution space. As I could gather from respected speakers, there are two concerns where support of OEMs are required. One on improving the life of the asset. I think we should now move from time-based maintenance to condition-based maintenance. For that, GET&D can support with range of digital solutions, which can be used with transformers, with circuit breakers, and with GIS. And the second one is addressing the sustainability issue. We are aware Government of India has done exceedingly well with the policy initiatives in terms of decarbonization by adding renewable energy in a massive scale. There is an opportunity in the transmission space as well. As we are aware, Sf6 being used as insulation and arc quenching medium in switchgears, and Sf6 is the most powerful greenhouse gas known to humanity. GE has innovated an alternative solution which is based upon fluoronitrile, which is being accepted as an alternative to Sf6 in various countries within Europe and in Scandinavian countries as well as in UK. We would like to work with various utilities and also with the Government of India, and would seek support from Government of India with policy incentives so that this technical solution can also be transferred to India, and we are able to support the government with sustainable solutions even in the transmission space. Thank you very much for this opportunity.
Thank you. Thank you. With all these inputs now, it's time to request our chief guest, Mr. Devangan. We are all keen to hear you now. Thank you.
Good afternoon. Director General, Indian Chamber of Commerce, Dr. Rajiv Singh, Mr. Tapan, my esteemed panelist, Mr. Rajiv Ghosh, Rajarshi Ghosh, Saurabh Banerjee, Mr. Rajput, Mr. Anjan Banerjee, and all the distinguished participants. It's my privilege to be among with you on this second edition of Smart Switchgear and Controller, which has been organized by the Indian Chamber of Commerce. I must congratulate ICC that they have timely organized this very timely event where we all need to sit together, and I was benefited by the concerns or issues raised by the distinguished panelist. As you are all aware that hopefully we are at the end of this COVID pandemic. Now third wave is almost over, and last 2 years have been really very difficult. And I understand that everybody or their near relatives, everybody has faced the difficulty during this global pandemic. And globally, switchgear industry has been significantly impacted by this COVID-19 pandemic, where major raw materials and products were highly affected. The economic shock caused by pandemic has negatively impacted the investment in the power sector. But now we are on the revival path. As I can see from the consumption of electricity, which is growing at much faster pace. I was just comparing the figure that last 4 years, the maximum consumption of electricity was in 2018-19. Now, in the current year, 21-22, we already exceeded the 2018-19 figures, which was the largest for the last 3-4 years. And we are poised for an economic recovery. I see that better times are ahead of all of us. Let me give you just a brief background about the initiatives taken by the Government of India. You are all aware that we had taken up this village electrification, was completed in record time. Thereafter, we connected each and every household that under Saubhagya scheme, about 2.8 crore households were given electricity connection. Now, the question of access has been almost sorted out. Now, the expectation of the consumers are increasing. They want reliable quality power. That is, and that too 24/7. And the world over energy transition is taking place. We are all aware that the world is moving from fossil fuel to the non-fossil fuel. And Honorable Prime Minister had announced the enhanced ambition in the COP26, which was done at Glasgow in the month of November. He had announced the 5 element that is called Panchamrit, that we are targeting to become net zero by the year 2017. Here I would like to mention that most of the developed countries have given their ambition of becoming net zero by the year 2050, and while China has given the target that they'll try to become net zero by the year 2060. But when we compare the per capita consumption of electricity and per capita emission of carbon dioxide, India is much below the world average. Our stand is that we are a developing economy. Our people also have developmental aspiration. Per capita consumption will definitely increase. Right now, we are only 1/3 of the world average. There are developed countries which are consuming, like per capita consumption electricity is more than 8 to 10 times of the world average. And these developed countries are showing us that they have already occupied this carbon space, and they are giving us the sermons to reduce the carbon emission. Our stand is that we do have the development aspiration. In this process, our consumption of all these products will increase, and that our emission would also increase. But we are yet to reach our peak emission. Once we reach the peak emission, then our will be able to gradually scale down. That's why Honorable Prime Minister had taken the realistic objective that we'll be able to become net zero by the year 2070 only. But among the G20 countries, India is one of the leading torch bearers, which has been able to maintain the commitment given in the Paris Agreement. We had given commitment that we'll be able to reduce our carbon, will reduce emission intensity of our economy by 30 to 35% by the year 2030. Now the Prime Minister has given us the enhanced target that will try to reduce our emission intensity by about 45%. Then we are also targeting that to have 500 gigawatt of installed capacity from non-fossil fuel, and we'll be able to meet our this energy requirement by the year 2030, and 50% of it will come from renewable energy. And we also had to try to bring down the carbon emission by the year 2030 by about 1 billion ton. All this would require the integration of renewable energy into the grid. And it will also require the storage solution. Without storage solution, will not be able to scale up this renewable energy. Why I wanted to highlight this aspect was that under this backdrop, there is necessity of a smart grid, and will require the smart grid, and smart grid will require smart switch gears. And the sky is the limit, I must say, for the switchgear industry. And I had asked Mr. Tapan Chattopadhyay ji to kindly share with me the market of the switchgear. He has been kind enough to share with me that this switchgear market consists of low voltage, medium voltage, and high voltage switchgears, and total industry is going at the rate of compounded annual growth rate of about 7.2%. That is quite significant. And the total market share of three components of the switchgear is about 20,000 crore. And I'm happy to learn that we have been exporting the switchgears to the countries like Bangladesh, Sri Lanka, Vietnam, Africa, Latin America, and our exports are to the tune of about 2,000 crore. Here I would like to, and my colleague Rajput is there. We are part of a team that we have made a policy for promoting Make in India. In fact, we are coming up with phased manufacturing plan to promote domestic manufacturing, particularly those items. And these are most of these items are in transmission and distribution sector only. The items which we have been importing, we want to develop our domestic manufacturing capability. For that, we are also planning to bring some production linked incentive also. You'll see that lot of action in near future. We have also decided to set up 3 manufacturing zones where we'll giving all the concessional facilities for the industry to set up their facilities there, and particularly compete for those items which we have been importing so far. We want our domestic industry to go. Our domestic industry should be able to manufacture those items. For that, we are taking up one pilot project initially. For that, we have recently got approval of Ministry of Finance. About 400 crore has been allocated for that. The government has also approved revamped distribution sector scheme, that is RDSS, where we are planning to install smart prepaid meters. About 25 crore smart prepaid meters are going to come. All this will require this smart grid and smart management of this all this equipment. So there's huge potential for the smart switchgear industry. I have noted down the suggestions given by Mr. Rashi Ghosh that we need to better utilize the assets, and there should be detailed discussions with the customers before we make any change in the product. And we also should think about this pair support from the OEM. The data analytics part also he has emphasized. I'm fully on board with him, and he has also raised the issue of software compatibility and the standardization of this open source platform. That is also very much required. In fact, keeping in view this cyber threat, we have formed a team in the Ministry of Power to take care of this software related issues. Also, we are also coming up with a vendor policy for the software that we are working closely with all the Ministry of Electronics and METI. We are working closely with them. We are also working with the National Security Council because a lot of security aspects are also there. The sustainability issue has been raised by a number of speakers. We are fully on board. We would like to promote this Sf6 gas manufacturing in India if possible. Mr. Partha had raised the issue of failure rate of relays. That is really a cause of concern. And he has raised the issue that tender specification across the utilities need to be made uniform. And we are working on that, so that for utilities, we are working out we had asked Central Electricity Authority to work out this standard for the technical specification, so that when utilities are floating tenders, they should follow the minimum technical standards, so that there is not wide variation when utilities are inviting tenders. And Mr. Partha had also raised this very pertinent issue that we should not be for reactive maintenance, but it should be for preventive maintenance. And Mr. Rajput had also added that timely maintenance also, the preventive maintenance with timely action, that is what is required to be done. Mr. Saurabh Banerjee had raised the issue of this MSME. Yeah, we need to protect our MSMEs. There are challenges for the MSMEs, and Government of India is committed to give sufficient leverage to the MSMEs so that they are able to compete with this high technology components. Our MSMEs should be able to have collaboration with this technically capable companies or the partners. We are all for the promoting MSMEs. We like to have better technological collaboration for our MSMEs. There is need for setting up testing laboratories. We do understand, and in fact, our Central Power Research Institute, we asked them to work out this testing lab. Incidentally, I would like to mention that the manufacturing zone that we are planning to set up for about 400 crore rupee, there this common testing facility would be there. Whatever industry or whichever industry is going to come in this manufacturing zone, we are going to set up this common testing facility in collaboration with the Central Power Research Institute. We'll also be giving common infrastructure facilities along with testing facilities. Mr. Rajput had raised the issue about the risks associated with the switchgear installation, and he also had driven home the importance of good housekeeping and timely maintenance. And Mr. Anjan Banerjee has rightly pointed out that support of OEM for improving the life of our equipment is very essential, and sustainability issues, decarbonization, we are committed. In fact, let me tell you that we have worked out detailed industry decarbonization plan. When we are making our pathway for reduction of carbon emission by about 1 billion ton, we figured out that most of this emission reduction or decarbonization will take place in the industry. Industry is the topmost, then transportation sector, then building sector. Building sector has tremendous potential, both commercial and residential building, because this use of air conditioner and consumer demand has been increasing. There's huge scope for decarbonization. Then electric vehicles, electric mobility is coming up in a big way. In fact, Ministry of Power is fully supporting this setting up of the charging infrastructure. The crux of mentioning all this is that Ministry of Power is committed to promote smart grid, and in this smart grid, the role of smart switchgear controller is going to be very important. And I wish that the domestic manufacturers of the smart grid and controllers will get ample opportunity. Let me assure you that economy is recovering and sky is the limit for you. And we are there to give all kind of policy facilitation. Thank you so much.
Mr. Devangan, thank you. Thank you for ending on a very positive note. And it's truly heartening to know about all the initiatives which you at the ministry and ministry as such is driving to promote Make in India, to bring in the reforms, to fast track technology adoption, and to make entire sector competitive vis-a-vis the global suppliers. I think it really goes very well for the industry, and the kind of initiatives you mentioned, including PLI, which is being worked out. I think definitely the sector is going to witness huge demand coming up, and of course the preference will go to the quality products, and Indian industry will not lag behind in matching the standards and also making cost competitive products. So with this, I think this first inaugural session really ends on a very positive note. And from the industry, we would like to be in touch with you and interact with you, because ICC is very proactively working in the sector, because we engage at multiple levels. There are certain conferences, events, awards, policy reports. One point of time when 3 years back or 4 years back, we had even done a report on manufacturing of solar panels in India, and what are the impediments and what government should be doing. And I'm happy to mention that that report was inducted in the government policy, which was announced later. So we look forward to working with you. With this, may I once again thank you, and I thank all our experts. May I now hand over the mic to Tapan? Thank you. We are truly thankful to you. May I now hand over the mic to Tapan to take over and conduct the next session. Thank you.
Thank you.
Thank you, everybody.
Yeah. Thank you for the participation. Thank you, Mr. Devangan, and thank you, Dr. Singh. Now, as we all know that in every switch, there is a switch gear behind. So it is the practically watchdog for the entire power sector. We'll start the technical session and discuss about the different aspects of the technicalities involved and the development that should be taken up. First of all, in this technical session, I would request Mr. Parthapratim Ghosh to present. Mr. Parthapratim Ghosh is a technocrat, is a senior professional in the medium switchgear over a span of 37 years. He has worked with the switchgear houses like GEC, Aston, Andrew, ECE, Isun, Rayrole, and Stelmac. So I would request Mr. Parthapratim Ghosh to present his presentation. Over to Mr. Ghosh.
I think you are on mute.
Am I audible?
Yes, yes.
Yeah. Thank you, Mr. Chattopadhyay, in fact, and also Shima, for giving me a privilege to be a part of this very, very important session. An interaction, the first round, it has started with a very positive note, definitely, and really it is beneficial to me personally and to all whoever participating today. May I request someone to upload the PPT before I start? Welcome to everybody. This is a second session of the deliberations and interactions on switchgear. And very rightly, today, in fact, my topic will be the evolution of medium voltage switchgear, circuit breaker being a very important part of it, rather the heart of it. And the total journey is an evolution towards a smart grid. The first session, it was more focused on the necessity of a switchgear to be aligned with a new situation, which we have encountered all very badly over the last couple of years, that is the COVID, which made certain situation compulsion for us, for example, to keep the footfall at substation at a very minimum level, and that required drastic action to have the operation from remote. And quite logically, the next step should be smart grid and the smart switchgear, which will ensure that. So that is why, in fact, very aptly in the second session round of discussion on switchgear is smart grid and smart switchgear. Next. Just to have a refresh, rather, what a switchgear is and what a circuit breaker is meant to perform. So basically, a circuit breaker, medium voltage circuit breaker, is also a circuit breaker, a switch rather, and its function is to interruption of all sort of faults, fault current or over voltages. That is the major function, and that keeps it apart from other ordinary switches, on-off switches. It's a very specialized function of a circuit breaker. And the brain of a circuit breaker is certainly protective relays, because a circuit breaker operates by the command of a relay. So the circuit breaker performs interruption, fault, short circuit protection, cable switching, overhead line switching, capacitor bank switching. And there is a standard operating cycle. Next. Let us have a glimpse on how the switchgear is placed in the total grid from generation to distribution. Next. This is bird's eye view, how the power is generated and finally goes to the ultimate utility. The encircled portion, the below left corner, that is the distribution segment, and medium voltage switchgear rated typically of 12 kV and 33 kV is placed and is functional in this particular domain, not in the transmission segment. There are different kind of EHV circuit breakers for that. Next. This is a typical schematic of a substation architecture, where typically the supply comes through a 33 kV circuit breaker, goes to a transformer, step down to 12 kV level, and there are typically 3 12 kV breakers, and from this breaker it is fed to the next line rather to LT segment and to consumers. And there are control panels at the left hand side, and protective relays are there. Again, to repeat, rather, relays are the brain of a circuit breaker and switchgear. There are instrument transformers also. This is for general understanding of the switchgear first before jumping into smart switchgear. Next. There are 4 major building blocks of a circuit breaker. First is controller, which controls the function of a circuit breaker. Operating mechanism, which is a mechanical device, and through a mechanical linkage, it goes to the interrupter. That is the portion of the circuit breaker which interrupts the faulty currents. So these 4 major building blocks make a complete circuit breaker. In the next slide, rather, there will be some glimpses on how the circuit breakers in fact evolved in terms of interruption of fault current. There will be a different media rather where the arc interruption takes place. Next slide. Historically, the air circuit breaker came into being first, and typically that versatile man, Thomas Edison, he first conceptualized a circuit breaker also in a way back in early 17th century, but the commercial implementation, it happened around 1880. Next technology came, oil circuit breakers, in both the form of MOCB and BOCB, that is minimum oil circuit breaker and bulk oil circuit breakers. The difference of air brake circuit breaker and oil breaker is in the arc quenching medium and the insulation. In case of air circuit breaker, the major insulation is air, and the arc interruption happens also in the air. There is a different version of air circuit breaker which is still in use, particularly in EHP segment, that is air blast circuit breakers. Oil breakers, circuit breakers nowadays are almost obsolete. It was implemented in around 1925. Next technology came into being is the Sf6 gas breaker, and a lot of debates are going on because of the greenhouse gas effect and on Sf6. That is why, in fact, already it was discussed rather there are alternative gases that are being thought about to replace Sf6. That is a different discussion, part of a different discussion. It came into being Sf6 in 1950. And the next technology was vacuum circuit breaker, which is still evolving. It is very much predominantly used in the medium voltage segment up to 33 kV. Now, still, in fact, development R&D action is going on to implement it at EHV segment also, that is 66 kV and above. Some implementation is there for 66 kV, But beyond that, it is still under development rather, and commercially is not viable. Next is GIS. Hello. Let us go back to the previous slide. It was not complete fully. So next was GIS. GIS came into being in 1967. Basically, GIS is also the same circuit breakers. That is, it takes the help of Sf6 or vacuum circuit breakers, but the insulation is, in fact, it is made of Sf6 by and large till now, just to make the overall switchgear very compact. And the next evolution, which is still evolving and in a very nascent stage in our country, is smart switchgear. That is our topic of today. Next. Smart grid is the driver for smart switchgear, because the necessity of smart switchgear, it evolves from the smart grid requirement. Now, smart can be implemented, in fact, interpreted from its abbreviation like this. S stands for sequential data, M stands for measured, A for acquisition of data, R is real-time communication of data, and T is the timely action, which is the final objective of smart grid rather. Next. Transition, how the normal conventional grid, it evolved into smart grid. Let us have a glance on it. This is a bird's eye view of conventional grid. Just for general understanding, grid is nothing but the interconnection from generating stations up to the consumer level. From generation, it goes to the transmission segment, then to distribution segment, sub-distribution segment, to the final end user, that is to building, industry, and many other applications. So this is, in a nutshell, is the total grid. That is from generation to the final consumer. The entire connection for the flow of power and electricity is the grid, conventional grid. From conventional grid, we are evolving into smart grid. Next slide. This is the conceptual schematic of a smart grid. At the four corners, we can see that there are four kind of power generation centers. One is thermal, nuclear, solar, and another is wind power, that is renewable energy. So the one important factor of a smart grid is to make a provision and flexibility to adopt the new resources. And renewable energy is a very important factor of that. And also in the middle, four circles rather, we can see four different consumers, which starts from factory, building, smart buildings, and also the electrical vehicles. So entire consumer band of consumer and the entire generation band of generating stations, along with the transmission and distribution line, is interconnected in a smart grid in two ways. First, as a flow of power, a flow of electricity, and secondly, also in parallel, a flow of information between all the segments. So that is the smart grid. Next. Inwards. Conventional grid delivers electricity from power generation to consumers to transmission and distribution lines. In contrast, smart grid introduces two-way interchange where, along with electricity, information can be exchanged in both directions between power utility and consumers. So that is, for easy understanding, the difference between conventional grid and smart grid. Next. The same thing in a more simplistic way. We can see here, there are three blocks: generation, transmission, and distribution. There are power flow from generation to the final distribution, residential, commercial, and industrial. And on the top of it, we can see in the dotted line, there is a flow of information also. So the flow of electricity as well as a flow of information to wireless communication, to communication protocol, that makes the smart grid. Next. Switchgear is one of the substation components of smart grid. So smart grid provides the platform which generates the requirement of smart switchgears. The major components of a smart grid are power substations, which include medium voltage switchgears, power generation centers, transmission distribution lines, controllers with communication protocol, collector nodes, smart meters, transmission and distribution control centers. In a nutshell, these are the components of smart grid. Now we'll come to a pictorial version of it. Next slide. So whatever in fact component we have seen in the previous slide, it is put in a pictorial way. In the left hand corner, we have seen there are two power generating sources, alternative power generator and prime power generator, along with the smart controllers. In the next segment, transmission system, transmission substation, along with their controllers, then distribution segment, distribution substations, and their controllers. Sorry. And here we can see rather there is the bolt lines indicative of flow of electricity, and the dotted mesh, the interconnecting mesh, that indicates the communication grid between all segments. The communication happens in various ways. We'll have a different slide on that, just to have a highlight rather. A smart meter is a very important part of smart grid because that is the final objective. And there are Zigbee, there are IP protocols, and the mobile network that helps in forming the communication network in a smart grid. Next. Why we need a smart switchgear? To integrate switchgear with the smart grid power management drivers. This can be easily monitored and managed from remote to answer market demand for improved efficiency and reliability, to ensure preventive maintenance in place of reactive service, reduction of downtime and loss, reduces manual intervention and substation operational cost, easy upgradation of line switchgear to intelligent switchgear. So that is the answer why we need a smart switchgear. Next. Next slide. How smart switchgear works. From left, two-way real-time communication through wireless optical fiber architecture. There are sensors which monitor temperature, current, voltage, humidity, insulation, and so many other factors. Recognize failures, communicate data about a possible breakdown in advance. Then data is sent to the central data management system. Data is analyzed. Remote signal goes through ID relays to make or break a circuit breaker from remote automatically based on the nature of faults. And very, very important part of it, which is singularly an attribute to smart grid, is preventive alert to station for immediate service, because there are sensors which can preemptively sense Today there is not a failure, but maybe in coming weeks or months or years, there are a certain part of the substation which may fail because there are signals for these future failures. So this data also through sensors and wireless communication, that is also collected, analyzed, and fed back to the substation for taking advanced actions before the ultimate failure. So that is one of the very important aspect of smart switchgear and smart grid as a whole. Next. Now, the key values of a smart switchgear or smart grid. It ensures 66% less cables and up to 10% less connectivity components, 7 to 20% energy efficiency improvements, reliable and simple to service, enabling up to 36% less maintenance cost, upgrade and update solution with zero downtime. The last two is very, very important. Next. It's blank. Yeah. We are having a glimpse on different type of communication protocol because the smart grid as well as the smart switchgear very much works on communication. Particularly the relays and meters, it will have a different communication protocol which communicates a signal remotely. You press the page down button, the menu will come. Yeah. Page down, page down. Yes. There are four major communication protocols, just for easy understanding rather, because this is a very typical and specialized subject, will not have a very much, just to understand rather how communication is very important for smart grid. This is just a general bird's eye view. RS-232 port, that is a very, very, in fact, still it is in use for some dedicated application. This is a 9-pin serial port communication, but the maximum distance to download data is 15 meters to 9600 bps, and maximum one number device the data can be received from. On the contrary, RS-45 is more advanced rather, so it collects the data and communicates data A, data B, and ground serial flow ports also. It covers a much higher distance and also at a higher speed. There is Modbus communication protocol also, and optical fiber ports are there, RJ45. So these are the various kind of communication protocol, and through this communication protocol, the ordinary mobile network also, it can carry the signals, and for monitoring and control rather, even over the hand mobile, there are apps rather, it can be downloaded on the mobile. There will be passkey rather, so that in fact the access should not be there to everybody. So based on that, even it becomes a mobile station rather with the respective officials, so that the data can be seen, the signals can be seen, and the control can be ensured through a cell, a mobile. So in that way, smart grid and the smart switchgear is really a smart and intelligent device. Next. Now, in fact, we have covered and understood rather what is the purpose of a smart grid and the smart switchgear. Now, to adopt all these smart features rather, let us have a glimpses on the MB circuit breakers for everybody's understanding. Next. There are various kind of circuit breakers, medium voltage circuit breakers. The middle one is the outdoor circuit breaker, and the separate control panel, it drives the circuit breaker, enables him to switch on and switch off. And the left hand side is a indoor circuit breaker where the control panel is inbuilt in the same panel. Next. This is the circuit breaker portion of the indoor circuit switch gear. Next. This is a specialized switch gear for secondary switch gear application. This is RMU. There are various combinations. In fact, in outgoing, this is a combination of circuit breaker and isolators. The typical combination is the middle one becomes a circuit breaker and the outer feeders are isolators. Next. This is a very specialized and intelligent special application switchgear and circuit breaker. This is pole mounted auto recloser. This is itself is a very intelligent circuit breaker and a smart switchgear. Next. Schematically, in fact, in a simple way, let us understand how intelligent auto recloser works. Auto recloser is a smart switchgear which can automatically switch on and switch off. For example, there are 3 feeder lines and there is a fault in the L3. Let us come back to the previous slide. Yeah. So there is a fault in the 3rd feeder. So there are sectionalizers, there are respective controllers which communicate with each other. So finally, when there is a permanent fault in the line 3, after 6 count, the auto recloser, it finally opens and never close, auto reclose. But the sectionalizer opens and it allows the line 3 to be isolated from the other 2 so that the supply line is restored in the line 1 and line 2. So in that way, this is itself is a very intelligent switchgear and a smart switchgear. This is just to give an example rather how smart switchgear works intelligently. Next. Now let us come to the market and the relevance of a smart switchgear, because unless there is a market, nothing will survive. Smart switchgear is part of our overall switchgear market, both in India as well as overseas market. Indian switchgear market size is projected to grow at a CAGR of 6.7% during 2020 to 2026. Importantly, increasing infrastructural advancement, including smart cities and rising number of solar power plants, are increasing the demand of a smart switchgears. So whatever the total market switchgear market is, a sizable portion is gradually going into the domain of a smart switchgears. There is no doubt about it. Next. This is just a glimpse on where we are in implementing smart grid in India. So in 2015, NSGM was formed, that is the National Smart Grid Mission, a separate body. It was formed in March 2015 and it was operational since 1 year later in 2016. Throughout this period till now, 12 projects, pilot projects have been completed at various states, and there is a list rather and in the map also, and 4 other projects are in progress right now, which is not yet completed. So total 14 projects as of now, in fact, we have adopted, but there is empty green field rather way forward, because we have in fact total 76 utilities distributed in 28 states and 8 union territories, and most of the utilities rather they are yet to implement a smart grid. But the projects, there are government investment, as was highlighted in fact in the previous session, introductory session, it was already highlighted. There will be massive investment, and till now in implementing this 14 pilot projects. Government already has invested 673 crores. Much more investment will come. So definitely smart switchgear is the future of switchgear, and we have to catch up with that. Next. This is the total list and the investment breakup for different pilot projects of the total 14 pilot projects. Next.
Ghosh, kindly be short because we are.
Yeah. This is the last slide. This is the last slide. Here, in fact, there are challenges. We have captured the challenges to implement that. And the last line is very important. Still, the major torchbearer for smart switchgear is the multinationals, that is ABB, Schneider, Siemens. They are showing us the light. Now, as a part of Atmanirbhar Bharat, rather, we have to encourage, in fact, others should join the band. That is very, very important. For that, the R&D investment will be required, rather. And we hope, rather, there will be support from government. And with that, that is the end of my presentation. Thank you.
Thank you very much, Mr. Ghosh, for your extensive information about the switchgear to the utilities of utilizations of the smart switchgear. Now I will invite Mr. Rajarshi Ghosh, the General Manager Substations, CESC Calcutta. He will speak on the sustainability of modern switchgear, the sentinels of transmission and distribution network. Let me give a brief introduction of Mr. Ghosh. Mr. Ghosh is the BME from Jadavpur University, and he's the General Manager Substation for the CESC Limited. He's managing operations and maintenance of the various electrical equipments in transmission and distribution stations in CESC. He is responsible for planning and execution of the projects, including installation, commissioning of new substation, taking effective cost-saving initiatives, ensuring quality and enhanced productivity. He actively participates in different national, international seminars, conferences, the purpose of knowledge sharing and implementation of new technologies. Over to Mr. Ghosh.
Yeah, good afternoon. Just sharing my screen. Is it visible?
Yes.
So the screen is visible to everyone, no?
Yes.
Yeah. So good afternoon, ladies and gentlemen. I'm Rajarshi Ghosh from CSC Kolkata. Today, my topic is sustainability of modern switchgear, the sentinels of transmission and distribution network. Now, the time is short, so I will try to discuss it in brief, touching upon the main aspect of sustainability in the switchgear industries. Now, we all know that electricity is the backbone of present society, at least in the urban areas. And there will be, if there is no electricity, without electricity, there will be chaos in urban areas. So water supply, healthcare, education, business, in every sector, electricity is essential. And as an utility, we must ensure safety of our operators as well as our customers, improve the reliability of the entire network, confirm the quality both for material and service, and maximize the efficiency so that our customers are satisfied. Now, in this competitive environment, regulated environment, customer satisfaction is not enough. We have to move ahead for customer delight. Now, in this switchgear industry, how this switchgear helps us to achieve all these things. So Mr. Ghosh has already described many things, so I'm going very short. Number one, it senses the abnormalities in the system. It can discriminate the faults. It senses the abnormalities through the instrument transformer, CT, PT, different sensors, and it has the power to discriminate the faults with the help of protection logics. It can isolate the faults through its relay signals and everything, protection system. It must act fast to avoid any catastrophe. If it is not tripped in time, then there may be catastrophe, there may be larger failure, there may be shutdowns. So it must act fast. And finally, it ensures the reliability of the system, which is, as an utility, our main motto. So now today, we are briefly going to discuss about the evolution of switchgear, past and future, very short. Then GIS, its advantages, that means the gas insulated switchgear, the modern switchgear system with Industry 4.0, IoT monitoring, analytics, etc. And finally, the sustainability, our path forward. So let's start with the evolution. It is already, details has been shared by Mr. Ghosh, but still, you all know that initially we have the bulk oil circuit breakers with huge size, huge quantity of oil, very heavy, labor intensive, with requirement of regular maintenance. And at least for last 80-90 years, we have only those bulk oil circuit breakers. After that, bulk oil circuit breakers, to reduce the oil quantity and the fire hazard, the MOCBs, the minimum oil circuit breakers, came. But still, those also needs the higher maintenance, the oil replacement, all these things need to be done. Then came the AIS, that means the air insulated switchgears, which are much lighter and easy to maintain, but it is also not maintenance free. It has some exposed parts. It is exposed to the atmosphere in many cases and prone to tripping. Already, Mr. Devangan has told, Mr. Rajput has told that their varmint proofing should be there. So all these things need to be properly cared. Finally, the totally encapsulated, this gas insulated switchgear came. This gas insulated switchgear is entirely covered. There is no exposed part. So it requires very little maintenance, and it is much more reliable than all its earlier versions of AIS, BIS, MOCB, and previously the air circuit breakers all. So it's require very little maintenance. And now we are moving towards the Industry 4.0. That means the switchgear with intelligent switchgear, which improve the reliability further. So if we now go to the GIS, in the picture you can see this is a large outdoor yard with huge land requirement, and in urban area land is like diamond. So it is huge cost is there for this land, but you can see a large outdoor yard can be replaced with a small GIS board, which can be installed inside the room only. So compared to AIS and outdoor yards, the footprint of GIS is 15 to 30% only, depending upon the configuration. And as the voltage level increases, the space saving will be more. Indoor and underground GIS are widely recommended in urban and highly populated areas where this land requirement is less for the GIS. And in Kolkata only we have one substations where in the first level down, that means in -1 level we have a 33 kV GIS, -2 level we have a 145 kV GIS. So it is entirely an underground substation with EHT, EHV equipments, and normally cables come from the bottom for the termination. Here the cable came from the top to terminate on the GIS board. Now up to 245 kV level, the transportation conditions permit the factory assembled bay, which make it very easy to install and very short installation and commissioning time. Another few advantages are it has reduced or partially no regular maintenance is required. Almost everything is covered. Only the Sf6 quality checking or few dust cleaning and everything, these things, small things needs to be done. GIS is also considered for severe environment condition where there is saline pollution near coastal areas. Since everything, all the primary circuits are enclosed inside the Sf6 chamber, there is corrosion level is very less. So it is very easy to maintain in the corrosive atmosphere also. And GIS also gets preference when the substation is installed at very rough terrains or high altitudes, low temperatures, seismic considerations, hydro stations. So for all these aspects, GIS has modular design, so easy to install, easy to shift, and so these are the advantages of GIS. GIS are available from 12 kV to almost to 1200 kV. All the voltage ranges it is available. It's having single, double, and 1.5 breaker system, single bus, double bus, 1.5 breaker, whatever is required, it can be manufactured. It has indoor and outdoor installation facilities, so it can be installed outdoor also. There is no need to, only some shade is required due to the LT panels. And it has the modular compartment, so it is very much advantageous to install and maintain. Now with these smart systems coming on, we have the BCPU. Earlier we have the relay panels, relay control panels as shared by Mr. Ghosh. That earlier we have for each panel, each switch panel, we have on relay control panels. But now it is coming with BCPU. That means the bay controller and protection unit, which reduces the copper consumption. That means the multi-core cables, and also reduces space and cost, separate relay control panels by directly integrating it with the station automation system. You can see in this switchboard, here we have the bay controller units fitted on the switch panel itself. So there is no need to have a separate relay panel, no requirement of additional space. So it less requirement of overall space, reduced interpanel cabling, less maintenance requirement, and overall low cost. So this is a very, very smart system which has came a few years from now. We also have prefabricated substations in the medium voltage level, where we have in our housings or some industries or some shopping malls or like that, we can install this type of prefabricated substations. All functional units are being installed inside this metal enclosure, and the unit is entirely prefabricated and assembled in the factory with all routine and type tests conducted therein. The main advantages are compact design, easy installation, better aesthetics, and enhanced safety both for the operators as well as for the customers. The main thing is they're very easy to install, and without any difficulty, you can commission the substation within a very short time. So now the next part is the intelligent circuit breakers. With modern switchgear, we can have the advantages of remote monitoring, which ultimately helps us to optimize our OPEX. That means the operational expenditure to a great extent, and defer the capital expenditure investment by extending the asset life. Now, remote monitoring facilities are now already available for checking the integrity of the Sf6 gas system, status of closed strip coils, mechanism, operation of space heaters, the current, voltage, time, operating time, number of operations, temperature, humidity, all these things, it can be easily measured or sensed from the site field itself, and it can be communicated to the station or to the control room, where we can get all the requisite data for taking necessary actions. However, everything comes with a cost, and as I told earlier, unless we in our country we make all these things with this make in India movement, the cost will be exorbitantly high, and it will be difficult to install all this. All our assets cannot be equipped with this. Only the critical assets can be done. So this is one difficulty for this. Now, now what will be the fate of all this data? All this data is coming, say, for a transformer, for a switchgear, different parameters we can sense from the field. After sensing this, what will be the fate of all this data? The effectiveness entirely depends upon how we are going to analyze it. Data can be stored for many months or like that, but unless we analyze it properly, there will be it will not be effective. Our goal is to reduce the cost without affecting the reliability of the plant equipment, our network. We have already shifted from this reactive, that means the breakdown maintenance. We have to we already have shifted time-based long back. Then we have shifted to condition based, say 10-15 years back, condition based. Now we have to go towards this predictive maintenance, and for proper prediction, we require proper analytics. Unless this prediction is quite reliable, it will not be prudent to go for this. Reactive, that is breakdown maintenance, time-based preventive, then move towards condition-based. Now it is the predictive. The age of predictive maintenance has come. So this predictive maintenance, with this predictive maintenance, we can decrease the planned maintenance requirement, which we regularly doing due to the earlier regime of time-based. We can decrease the service losses. We can lower the risks of the plant equipment and the operators. We can improve the workforce utilization, asset availability, recover our revenues faster, and mainly the replacement planning that also will be smart. That means wherever the actual replacement is required, then only we will go for the replacement, otherwise not. So the opportunity is huge. Only we need to use proper tools to analyze the data timely and effectively. In this modern system, the communication, Mr. Ghosh has already told that the communication between all the instruments started playing a very, very vital role to ensure this reliability. And internationally, this IEC 61850 standard came, which we all must follow for standardization of the system. Presently, the optical fiber, CTPT, etc. are available in the market, which are very easy to handle and can be used against all applications with much simpler connections. There is no need to say in our case, we have a backup core, we have a main protection, main 1, main 2, all these things. There are many cores are required, but for optical fiber, the same core can be used for different applications. So the equipments also become smaller in size, lighter in weight, and one multi-purpose CTPT can be used. Digital monitoring, measurement, control, and protection based on IEC 61850 are integrated into the local control cubicle within the bay. This reduces the copper connections and requires also less maintenance, reduce the cost. With the concept of this modern digital substation, we can reduce the multi-core copper wirings to a great extent with the IEC 61850 communication backbone. Here we have the 3 levels of instruments. Number 1 is the process level or field level, that is the circuit breaker, transformer, whatever be the field equipments. There the sensors are there. From the sensors, there is a merging unit. So from the equipment to the merging unit, it is known as a field level or process level. From merging unit to the bay controllers, which controls all the activities for bays. So this is called the bay level. And from bay to the control room, it is called the station level. So these are the main few steps. That is the process level, bay level, and station level. This is the architecture of a digital substation. Now, you can see this is the architecture what we follow in CSC for our sensors, which are IoT sensors, which is already installed in many plant and equipment, and from there we are getting the data. So here you can see it starts from the sensors fitted on the equipment, say the temperature, humidity, gas density, different parameters. We are sensing this. There is a gateway inside the station itself. From there, it is now going through a GSM network, through a client cloud, and coming back to our server through a firewall. And from there, we have our own software developed by our internal team, and we can see all the parameters, their analytics, everything we can see here. But presently, these are coming through the cloud. But in future, our existing SCADA is more than 25 years old, so it is going to be replaced within this year or like that. And whenever it is going to be replaced, this cloud network will not be used. It will directly comes through the SCADA network. That means our own optical fiber network. So it will be much more reliable. So this is the architecture of these remote monitoring facilities for CSC. Now the another other than improving the process, quality, efficiency, etc., another aspect of sustainability is the care for our environment. You can see SF6 is being successfully used for last more than 40 years for arc interruption and insulation of HV transmission, MV transmission distribution equipment, for its unique combination of unmatched dielectric strength and arc quenching capabilities. It is very high insulating capacities there for sulfur hexafluoride, but it is also the most powerful known climate warming greenhouse gas. So accelerating the transition to a carbon neutral energy system to enable technology and new business models to support scalable, flexible, and secure sustainable energy systems, we have to adopt policies and regulations. You can see SF6 has almost 23,000 times more global warming potential GWP than the CO2 itself. If CO2 is 1, then SF6 is 23,000 or more. Here you can see two pictures which I have taken from the internet. You can see for a 400 kV GIS filled with SF6 gas, the major part of the carbon footprint, or more than 80%, is due to the presence of SF6 inside the panel. So rest entire material is only for 20% or like that. So SF6 has a huge potential of global warming, which needs to be reduced. Here there is a plot showing the recent increase in SF6 concentration inside our atmosphere. It is in parts per trillion. In 2010, it was in 5 to 6 ppt, but now it has almost doubled. That means near 10 ppt or like that. So what we need an alternative environment-friendly gas having comparable insulation property with SF6, physically, chemically stable, easily detectable so that the leakages can be detected easily. Option for retrofilling because of we have the huge number of old GIS. Presently in CSE only we have more than 900 GIS bays in 220 kV, 132 kV and 33 kV level. Standardized for all product range. That means it should be the gas should be same for the voltage levels as well as different types of manufacturers. Easily availability and minimum cost impact. So all these things need to be addressed. These are the few alternatives of SF6 gas. Many manufacturers are coming up with, say, some nitrogen, carbon dioxide, clean air, this C4FN, fluoronitrous, and this G3. So all these things, they are coming up with these alternate solutions. This is the excerpt from this ASEAN Sustainable Energy Week 2021, where the 7 key factors have been identified for the sustainable energy and future. Ensure reliable, affordable, and sustainable energy supply to support the sustainable economic growth. Contribute more towards renewables. Use of advanced technologies like BESS, battery storage, and cleaner use of energy. Digitalization and artificial intelligence driven technologies. Embrace emerging and cleaner technologies like green gases, hydrogen, etc. Access to sustainable competitive capital with accelerate the energy transformation journey. And to make it happen, we, the stakeholders, should collaborate for the transformation of the energy landscape. Lastly, initially already I addressed all these things. So as an utility, we want that these aspects should be taken up by the manufacturers or the government bodies so that these things can be ensured for protection of our customers, protection of our stakeholders, everyone. Number one is safety, no compromise on the safety aspects. That is the internal arc tests, interlocks, both mechanical, electrical, and the insulations. Faster obsolescence of the product, should not get obsolete very fast. Spare support should be available at least for 10 more years after the discontinuation of the product. Indigenous sensor technology and open software, it is very much required for this IoT technology, sensing and analytics. And the alternative for SF6, manufacturers should jointly come out with one gas instead of multiple solutions. So our biggest cost is not materials or servers or people, it's the lack of utilization. We must utilize our assets to the fullest extent. It dominates all other costs. So lastly, I can show you, this is a picture of our underground substation, which I have just told you. So this is the 33 kV GIS bay at the -1 level, and you can see the 132 kV GIS bay here. It is at the -2 level. So this is the first underground EHV substation in our country. So thank you. That's all from my side.
Thank you, Mr. Ghosh. And now I will request Mr. Saurabh Banerjee from Pascal Switchgear. Mr. Banerjee has 17 years of experience in Schneider in various departments from R&D, engineering, bid management, sales management, and now he is currently heading the product strategy of Pascal Industries Private Limited. He will make a small, short presentation, and at the same time, I will request all the other speakers to give their presentations in a slightly brief manner, because we are really out of time. Because of the first session, it has consumed so much of time that will be difficult to close in the right time as we have decided. So over to Mr. Banerjee.
Thank you, Mr. Tapan. Am I audible?
Yes, yes.
Okay, so I'll switch off the video so that communication is good.
Yeah.
And I'll show the presentation. Thank you. So to start with, yeah, I'll be speaking in a very short presentation for this encouragement in the MSME sector, because today MSME is a big buzz and everyone is asking that how MSME is supporting Indian growth vision 2024, what our Prime Minister and our central government is seeing. But there are a lot of challenges in the MSME sector post-COVID also, which needs to be addressed so that we can sustain and we can also be a part of this growth division. So to start with, I'll just give a small I'll start giving a small presentation on our company, what we are doing. So we are basically Pascal Switchgear, which is having around 15,000 units footprint today all over India and outside also to Bhutan, Bangladesh, Sri Lanka, and some other parts of Africa. So here we are mainly manufacturing 11 kV AIS switchgears up to 25 kiloampere, which is our basically the star product, where we have our own breakers also. And then we are manufacturing 11 kV switchgears of 40 kiloampere as an OEM partner of ABB, where ABB is supplying the breaker and we are making the panel and the controlling system. Then we are also doing 33 kV air insulated switchgears with ABB as the breaker supplier. And then we are doing 132 kV control and relay panels and SCADA automation panel. So this is currently our profile, and we are also in the vision of doing a lot of R&D in becoming an expert in the medium voltage switchgear and low voltage switchgear in the coming times. So we normally we are building everything almost in-house. So we have a lot of completely integrated indigenous manufacturing unit with a complete green technology paint shop, which is been installed in our premises. We have punching, bending machine, which is installed in our premises, and almost 6,500 unit of assembly shop, which can cater to the various customers all over India. We have a team strength of around 400 people now in our family. But definitely in the recent times, we are seeing a lot of growth, and then this manpower skill will be very recently will go to 1,000. So we are consistently growing, and we have crossed 100 crores in just 7 years time of the launch of our business and products. These are some of our customers, which is almost we have penetrated 18 states out of 28, where we are supplying our panels, are installed for almost more than 5 years. We are giving a lot of switchgears to coal fields, central mines, Indian Railways, MES, and Public Works Department. These are all who are the government users of our product. Apart from that, there are a lot of private users also. And recently in Industry Outlook magazines also, they have recognized our company as the top 10 switchgear manufacturer of India. So coming to the topic, what I wanted to highlight, this is the encouragement of MSME for sustainable growth. There is a vision statement from Mr. Modi, Prime Minister, that MSME as the backbone of the growth story of India. And you will find a lot of encouraging statement from the budget this year also on the energy interventions across sectors, which will be around 9.2% of the economic growth, which is quite a high figure. Then we are having a plan of 280 gigawatt of solar energy by 2020, where there will be some PLI incentives for local manufacturing. So these are very encouraging statements from the Prime Minister as well as from central government, which are helping us to get motivated with the growth story. Then there are some statements from Mr. Nitin Gadkari, what we have noticed here recently, that this lower cost of L1 are no longer the only way to select bidders. This is a very encouraging statement for anybody who is looking for a technological growth and not on the price war. Because once we are investing in the R&D, we expect that the investment is being recognized on the basis of the technological brilliance and not on the price only. So these are some of the statements which are really encouraging for us. Then you find that with the Atmanirbhar Abhiyan, there was a lot of stimulus packages, which is almost of a magnitude of 3 lakh crores, which is a big amount to be pumped to the MSMEs in India as a part of this Abhiyan. So these some of the statements and some of the encouragements are coming from the government. But if you see as a MSME, as a real user of this, we are having still a lot of challenges to be implemented. And this implementation, without this implementation, you will find that all these packages will not be effective in the ground. So majorly, I have pointed out some of the key challenges respect to the power sector switchgear business on the MSME front. What has been mentioned for many many of the speakers today, that procurement of raw material, even after post-COVID, this is a big challenge which has come up for any of the suppliers of manufacturing unit, and particularly for an MSME who are dependent on a lot of big players like Tata Steel, like big players like Hindalco and Copper from China or somewhere else. This is a big impact to us. So that is going to that is impacting all our production cycle. Then there is a new recent times you will find that a lot of issues are with the microchip accessibility for relays and meters. Which is also impacting our complete delivery cycle and whatever commitment we have given. Then coming to the part of the product identification, that we are seeing a lot of specifications with a particular clause of 5 years validity. And as our honorable guest from CSC has mentioned, that we are expecting the product obsolescence as we should not be there. But this statement is actually contradicting that every time the specifications of the most of the utilities which is coming up are saying that 5 years validity of your type test and your product should be there. So they are always compelling us to have a retype test of the product. And once we are doing for that one, we are also going for some optimization and all those things, which is making our challenges to keep the product which is already there in the field for longer time. So there has to be some actions taken for this one, where we should be proposing that wherever you're making a specification, you go by the design specification parameters of the IEC guidelines, not on the year validity. So high cost of credit is a big challenge for us. That is already known to many of the MSME people who are working today. If you see today bank is giving a collateral for us for against the performance bank guarantee claims, which is almost for everywhere it is more than 5% or 10%. Today this kind of collaterals is only blocking the liquidity, and they're developing any product or making scaling up of for the product to be supplied to various customers. is impacted a lot, being a small player in this field. Then we have another issue with the design check and product approval. Today, if you see in the specifications, we are getting a lot of things which is written. But once people are quoting, and whenever somebody is participating in a tender, there is no process of proper approval of the product. Only some documentations are being submitted, and something on the paper has been verified, but no physical verification has happened, no stage inspection has happened. So we are finding that a lot of Chinese influence is coming inside our country also, where many of the products are getting camouflaged, and some inferior code technology has been pushed in, where the entire ecosystem is getting disturbed because of this kind of product, and the blame is coming on the entire manufacturing sector. So there need to be some kind of regulations or some kind of product approval authorities who can actually validate the suppliers by checking all the parameters. Then we get a lot of tenders which is on the farm pricing policy, which is a big impact. If you see today, since once the bid gets opened, after that the bid closing is almost around maybe 1 month, 2 months, or maybe at times 3 months, and we have been asked to give a firm price. Now farm pricing, we are not in a control of neither in the RMI indices, which is completely out of our hand. Then all the fuel cost and everything on the transport cost, everything is varying. There are a lot of stringent LD clauses also in the specification, which is impacting that whatever is the flaw for our inputs as well as for our outputs has been put back to the MSMEs only, where MSMEs are at the biggest hit point. So farm pricing policy is impacting a lot in any kind of MSME who are participating in big tenders. Then I think many of us has mentioned the same thing, that poor maintenance in the site. Since there are a lot of high warranty clauses have been put into the specification, we as a supplier are bound to supply to the customer on whether on the account that we are not the part of the maintenance. So whatever there is a flaw in the maintenance side, that has been put back on the clause of warranty, which is again hitting our deliverables and our liquidity for a particular product. So based on all this thing, what we want to say is that sustaining today for an MSME is a big challenge. But definitely, if MSMEs in this field, particularly in switchgear industry, is not there, then there will be another big challenge. What I want to highlight here. If you see the total market of today, medium voltage switchgear is almost around 40,000 units, which is going to cater to around 2035, if we project that this will be increased by 2.3 times the requirement of the entire market. So here, if you see the paradigm which has shifted now, mostly what we are discussing, that there has to be two ways. One is that MSMEs exist and they improve on the large scale manufacturing capability, on competitive sourcing from India and in the local areas. They create a lot of jobs so that many of the people can be employed, and boost economy and support break-even for the power utilities, because power utilities are operating in a break-even margin, so they cannot afford to have a lot of cost for this kind of switch gears or this from buying equipments. So definitely they have to buy in a low-cost environment where MSMEs can only support, and they can only cater to the large requirements of the customer. On the other hand, if you see the MNCs, what today we have in our countries, these MNCs are in need to invest in core technologies in R&Ds like smart technologies, where they are building online monitoring 24 into 7, AI maintenance, what artificial intelligence has been put into IoTs. This investment has to be more, and there has to be more encouragement for any collaboration with any Indian MSMEs, where their kind of chip technology or their kind of this sensor technology, which can be brought into India, and that can be delivered to all over the customers who are requiring this. So there has to be a balance, and there has to be a promotion for the MSME growth and sustainability in this sector. So what is the road ahead? How we can collaborate and sustain? So these are some of the points what I mentioned in the earlier slide. I will just brief that what is our idea and what is our proposal, so that that can be implemented on the policy from the policymaker side and from the utilities, from the users. If I go by raw material issue, this raw material issue can be resolved by liberating specification with surplus aluminium. Today most of the copper is getting imported, and we do not have a big control of this material. Whereas aluminium, we have a lot of material which is produced in India, and there are good quality of aluminium which has been produced from many of the government PSU, which can have good control. So definitely the specification can be liberated in that form. And there are a lot of technologies which has come up to ensure that the aluminium is also giving the similar kind of performances that the copper can give. So that will definitely help to ease out some of the raw material issue and fluctuating prices, which is dependent on foreign, I mean, on international issues. Then for cheap manufacturing, we have also already mentioned that it has to be. I think Mr. Devangan also mentioned that there are a lot of encouragement. So we should see some good growth in this. That cheap manufacturing has to be in India, so that we don't depend on our neighboring countries for any kind of issues with the international market. Then coming to credit liquidity issue, we are expecting that this can be done through a vendor financing scheme, because many of the PSUs are already into this, but government utilities are still on the open credit terms. So this will be ensuring that whatever we supply, we get our money on time, and that will be definitely put back into the system, and then the system can grow at a much faster rate. So then there is a lot of issues with the bank guarantee. Today, what we propose that if you can legalize with the banking system itself, that more than 3% BG cannot be granted. So that definitely will put back the pressure, and the specification can change that this can be managed with 3% BG, which will definitely increase the liquidity. Then coming to the credit case, if you see there is a lot of issues with the warranty. So once we are having some ANC contracts with definitely with the utilities and many of the users, that will minimize the defect liability period. So definitely that will increase the credit liquidity issue, because once you are not having the defect liability period for a long time, your BG can be get back to the bank, and bank can again pump in the finance back to the MSME. So this entire cycle can do quite a good if these three policies can be implemented. Then obviously for farm pricing, only two of the utilities what we see today is encouraging the IMA variation, and this IMA variation is having a particular formula, so everyone has to abide with the same formula. So the pricing can vary accordingly, and then it will be more flexible, and people can definitely participate with a much encouraging statement. Then we have type test validity, what we have mentioned, that introduce IEC based revision and design updation, not on the year based updation, because once your IEC is changing, if you see that today switchgear IEC has changed after almost 10 years, after 2011, and then 2021 is the last publication of the panel switchgears, and for the breakers it happened in 2017. So it can be, the clauses can be in that form that whenever the IEC changes, you can have a type test repeated and your product validation. But if you go on the validity of the years, then it is found that the suppliers who are manufacturing, they are also changing and implementing, and some of the things cannot be matched with the older supplies. So both the product line cannot be maintained on the manufacturing point of view. So that has to be somewhere nullified. Then product approval, as I said, that we can benchmark a lot of people from SAIL, PGCIL, and even CSC. There are people who are making a specification standard and following those specifications for any of the utilities all over India. So that would be helpful, that you have similar kind of requirement and the competition is fair, and the specification is well validated, well proven, no need to revalidate or re-understand. So that the process will also be faster, the product approval will also be smooth, and really some of the manufacturers who are developing in the product technology will be able to sustain. Then on the maintenance point of view, definitely some training calendar for all the skilled staff in the user sector has to be published so that we can also participate and we can provide the training which is required to have a better maintenance facility. Then, as many of the speakers has mentioned, like online monitoring system, which has to be implemented in the specification. And today the online monitoring system is like that you can buy out separately and you can install in the older switchgears also. So that is not that you have to come as a package. It can be installed in the old switchgears as well as the new switchgear. So that needs to be somewhere started. And once it is started, definitely the maintenance time and the higher warranty period, all these things can be easily maintained. Then we are also proposing that some essential spares need to be stocked. Means if it is not the case that as a manufacturer we cannot deliver you those spares or we don't maintain in our premises, but sometimes some spares which are very essential, these spares need to be stocked at your end because the lead time of the manufacturing of that particular spare is quite high. So this is impacting both way. As a part of the warranty, you are expecting that everything should be on the next day, but it is not possible to do it for as a manufacturer for us also. So definitely we are also expecting that based on our recommendation, you also review and maintain some essential spares. It's not that you maintain the entire thing, but you maintain some essential spares so that both way the burden can be reduced. So that's all. That is some of the key points what I wanted to mention. And if anyone wants to visit our factory, it's just South Chowbis Pargana. So anyone can come and visit and see our facilities. So we'll be glad to welcome them from the forum as well as from anybody in the community. Thank you.
Thank you, Mr. Banerjee. Now, because of the time constraints, we are almost 45 minutes behind schedule. So now I will skip the question and answer session. If anybody has any question, kindly send it to us so that we can send it across to the right speaker. Now I will invite Mr. Sanjeev Kumar Thakral. Sanjeev Kumar Thakral is an executive engineer of Uttar Pradesh Bijli Vitran Nigam, Government of Haryana. He will speak on the subject how circuit breakers ensure safety and reliability of power system. Give a brief introduction. Mr. Thakral is an electrical engineer from the REC Kurukshetra and joined UHBVN in 1993. Out of his 29 years of experience in metering and protections wing of Uttar Haryana Bijli Vitran Nigam for 25 years, and he is presently working at Sonepat. So over to Mr. Thakral.
Thank you. Good evening, everyone, and welcome to e-conference on smart switchgear and. First of all, I would like to thank ICC for organizing this conference and inviting UHBN. Next, I would also like to thank UHBN for the opportunity to work with us on this virtual forum. I would like to deliberate how circuit breakers ensure safety and reliability of the power system. In electrical system, different type of faults occur, which if not addressed promptly, can cause damage to the electrical system, resulting into dangerous accidents and fire, thus creating blackouts. To prevent such a harmful conditions, protection system is used, which consists of circuit breakers, current transformers, relays, and DC battery. The circuit breaker is one of the main equipment of protection system, and it doesn't know the fault diagnosed to the circuit breaker. The tripping coil of the circuit breaker gets energized, thus allows the circuit breaker to open the circuit. In electrical system, faults be avoided. So the healthy protection system is required, which runs into the relay system. What is circuit breaker? Circuit breaker is automatically operated switch which breaks the circuit in order to avoid damage caused by the overload or short circuit. It consists of two parts moving and the fixed one. Under normal conditions, these contacts meet each other, allowing flow of current and will not open until and unless circuit becomes faulty. Under fault conditions, relay senses the faults and gives signal to the circuit breaker. The tripping coil of the circuit breaker gets energized, which breaks the circuit and thus providing safety to the equipment from the damage. The generation of these electric arcs and arc is produced in the breaker at the time the circuit breaker breaks the circuit. The contacts of the circuit breaker must carry the load current without excessive heating, and at the instant when the contacts begin to separate, the contact area decreases and large current increases the current density, thus increases the temperature, which results in the heat produced in the medium, which is sufficient to ionize. The generation of these electric arcs are required to be controlled by the mechanism of circuit breakers in order to avoid the damage to the circuit breakers itself. Now, depending upon the techniques or the arc extinguishing medium, the circuit breakers are classified into oil circuit breakers, bulk and the MOCB, air circuit breakers, gas circuit breakers, vacuum circuit breakers, hybrid circuit breakers, and intelligent circuit breakers. Oil circuit breakers. Oil circuit breakers uses the oil as a dielectric medium. This type of circuit breaker is very oldest type and is rarely seen in today's system. Here the contacts open inside the oil. The developing arc vaporizes the oil, which forms a hydrogen bubble around it, and pressure generated contributes to the deionization of the arc. Hydrogen gas not only cools, but it provides good insulation also. Oils also helps for cooling the OCBs. In UHBN more than a decade ago, all the OCBs were replaced in UHBN. I remember that many employees of UHBN got seriously injured due to the flash occurred in OCBs, and few one also lost their lives. Oil circuit breakers are two types: bulk oil circuit breakers, minimum oil circuit breaker. In minimum oil circuit breaker, less amount of oil is used, so volume is less, so risk of fire is less. Next is the air circuit breakers. In air circuit breakers, air is used as the arc quenching medium. It is simple in constructions, have a compressed storage inside. Here the air is released through a nozzle and produces a high-speed jet of air, which is used for extinguishing the arc. ACBs are used for smaller voltage. No risk of fire as no oil is used. The disadvantage is that air compressor is required to create the high pressure air. Next, gas insulated circuit breaker, Sf6 circuit breaker. In gas circuit breakers, Sf6 gas is used as arc quenching medium. Here all the components are placed Sf6 gas. Sf6 gas has an excellent arc quenching electric property. Arc when arc is cooled by the gas. As the dielectric strength of high gas high so amount of current. It is non-flammable, so there is no fire. It is best suitable for urban area where space is main issue. It is not. It has more than 20,000 times global warming to CO2. Next is vacuum circuit breaker. In vacuum strength, the arc produces quickly extinguished as the metallic vapors and ions produced quickly condense on the circuit. The strength of the arc is very low. These are the most stable are the superior quenching property than any other medium. Vacuum circuit breakers are preferred over Sf6 breakers as Sf6 breakers are not environment friendly and is high cost. There is no risk of fire. In Uttar Haryana Bijli Vitran Nigam, there are more than 5,000 numbers 11 kV VCBs and 750 numbers 33 kV VCB. The average life of VCB is almost 15 years. Hybrid circuit breakers. Hybrid circuit breaker is a combination of type of circuit breakers can be installed for indoor and outdoor areas. The type of circuit breakers allows different functions in one module and have compact and modular design. The main advantage of compact hybrid circuit breakers is that their space requirement is more than 30% as compared to conventional air circuit breakers. These can be erected in polluted environment and extreme climates, and their erection time is also very less. Next is intelligent circuit. In addition to the basic task of the circuit technology, switchgear intelligent. The increased use of SCADA has resulted into demand for intelligent switchgears. Intelligent switchgear includes new intelligent electronics device with latest information and communication technology. Intelligent switchgear increases the efficiency and reliability of the power system. It can perform functions like system diagnosis, electric power fire predictions, and electric power demand predictions by using different sensors. Nowadays, severe problem is being faced in getting land, especially in urban area, particularly in NCR for construction of substations. And in the coming years, this problem is going to be more acute. On the other hand, power demand is increasing day by day. In order to meet future power demand and to avoid burden on existing power system, it becomes necessary to design compact and smart switchgear. Very old 33 kV substations are made in UHBN in 2 acres of land. Since last few years, these are being constructed in 1 acre of land. Nowadays, severe problem is being faced even getting land, especially in urban area, particularly in NCR, for construction of new substations. UHBN has constructed 3 number GIS substations and many more are in pipeline. These GIS substations have been constructed in 25 or 25 square meter area. But now we are struggling to get even this space for construction of new substations. Moreover, the cost of such substation is around 10 to 12 crore, which comes to be 4 times than that of conventional type substations. So the emphasis should be made to design hybrid substations there, which are environment friendly, smart and economical too. Quality aspect. The protection system does not include circuit breaker, relays, CTs and DC battery, but it comprises of these components with good quality material. Without good quality material, equipment's protection system is not reliable and hence there is no reliability of the power system. I am pleased to share that UHBN is very keen to install good quality equipment and is doing sincerely in this field, as a result of which we are able to reduce power transformer damage rate from 2.5% to 1.25% in last 5 years and are trying to bring it to less than 0.5%. Moreover, we are trying our best to reduce the power cuts or blackouts due to damage of equipments by using good quality material, and because of this, we are giving 24-hour supply to the consumers of 2,726 number feeders out of 2,976 numbers, which comes out to be more than 92%. And the target is to bring it to 100% in the current year. During blackout periods, the consumer starts using their generator sets. The consumption of 1 liter of diesel emits 2.7 kg of carbon dioxide. Now we can imagine the level of air pollution, particularly in industrial zone, during the blackout periods. Moreover, India imports crude oil. So these things show the necessity of reliable power system. Conclusion. Though we have different types of circuit breakers based on the arc quenching medium like OCB, VCB, ACB, GCB, etc., which are having their own pros and cons. It must be utmost priority of the switchgear manufacturing firm to strengthen their R&D wing so that they are able to develop a circuit breaker with some alternate arc quenching medium or some hybrid type so that we may have compact, smart, environment friendly and economical switchgear of good quality with quick installation features so that the citizens of India can be facilitated with uninterrupted power supply. As Mr. Anjan Banerjee told that they are using some alternate medium for the arc quenching medium. I will bring it to the notice of my management to consider for consideration of this new technology. Thank you very much.
Yeah, thank you, Mr. Takral, for a very brief but very good presentation. I will now invite Mr. Bipin Kumar. Mr. Bipin Kumar is the Business Development Manager of ABB Limited. Mr. Bipin Kumar is working as a Business Development Manager in the Distribution Solution business in ABB India Limited. Having total experience of more than 15 years in the field of design, product management, business development, and digital solutions. Over to you, Mr. Kumar.
Okay, thank you, sir. Can you kindly confirm if my screen is visible and am I audible?
Yes, both.
Thank you so much. So I'll try to be as short as possible, looking into the interest of the time. But first of all, thank you very much for giving us an opportunity to have our to have our say what we think on the topic on various eminent speakers just spoke about. So there are a few things where I could notice that many of the concerns, rather many of the opinions are moving towards in the direction of sustainability, moving towards in a direction of having a compact switchgear, and also how much benefit we can bring to the environment when it comes to electrical switchgear fraternity as a whole. So what I will do here, with the help of a conceptual, or rather with the help of a particular solution or a product, I'll try to explain that how as ABB we are trying to think in that direction, and also doing the efforts in leaps and bounds that how we can actually move ahead in the direction of providing a sustainable products and solutions to our various customers. So in that direction, I will just introduce one simple product of 12 kV systems. It is what I'm presenting to you is a new generation 12 kV gas insulated switchgear, because as at the start itself it is spoken, and we can all see that from the switchgear industry side we are trying to move from an air insulated switchgear towards a gas insulated switchgear. Of course, it is much more predominant on the 33 kV side, but then yes, there are many things happening, and many of the utilities are also coming up with the requirement of 11 kV systems. But then it is not only sufficient to have a gas insulated switchgear, but I think the most important part of here what we should look at is what we are using as a insulating medium inside. Predominantly more than 99% is Sf6, rather 99.99%. But as ABB, we have been trying to develop a few products in that direction in the last few years, that how we can replace Sf6 with something which is much more environmental friendly. And this particular product, what you are seeing, is a step in that direction, that ABB has been able to bring about or develop a gas insulated switchgear, which is able to work with Sf6 and also with dry air. Right, so this is a product which can interchange the insulating medium either right at the start if one buys it, or probably during the let's say service time of a switchgear. Changing the insulating gas does not change the service life of a switchgear. So it was 40 years earlier, it would continue to be that way. So this has been a very important, I would say, stepping stone from ABB in terms of the products and solutions development, how we are seeing the future going forward, because it's only a matter of time once people would realize to an extent that they can no longer avoid bringing a resolution which is probably trying to promote something which is an alternate to SF6. But then, as I would also request to the eminent people in the forum, because you all guys are very important people trying to shape up the electrical industry in India going forward. I think it needs to move in both directions. You know, in one of the direction, let's say as a manufacturers who are taking sort of a proactive step in trying to bring something which is much more environmental friendly, but at the same time, also make in India philosophy needs to be followed. So what we are trying to do here in ABB is we are trying to do everything in India. What I'm showing it to you as a picture is something which is done in our factory. But another step needs to be, as you also spoken about the various speaker, another step also needs to be taken by the government or the forthcoming utilities to try and experiment with these ideas. Because once we have any new technology in place, it's not, I would say it's not 100% true to form an opinion about the product unless you start using it and try to experience it. That's how the technology acceptance moves forward as we go along the years. So it needs to happen in both directions, and which we as a manufacturer are confident that in India we have very forthcoming utilities who are ready to employ new technologies and at the same time trying to solve their own issues and also trying to help the environment. I just show you very quick glimpses, but I would also request the audience not to relate 100% to this particular product, but this is something which ABB continues to work as a concept. What you are seeing here is, I am showing it to you, is a Make in India product, but then ABB also has a lot of, I would say, SF6 free product in the global portfolio once we go outside India. This particular GIS uses a single tank where you have only circuit breaker, but the bus bars are taken outside the gas tank. So you can access the bus bar in case you want to, but this bus bar are touch proof. You know, the surface potential of this particular bus bars is at 0. So it is accidentally touch proof bus bars, and also it gives you a very flexible maintainability. So the GIS technology is changing. We definitely see it changing in coming years because of the greater thrust on the environmental protection getting given by eminent leaders of India, and that is going to shape up the electrical industry going forward. So as a step in that direction, this is a greener GIS, what we call, because what we are using inside is a dry air. Dry air is nothing, in a very simple term, it's a mixture of oxygen and nitrogen with humidity taken out. So it is as simple as environmental air what we have used. And by doing this, the global warming potential is near to nothing for this particular switchgear, and works perfectly 100% as a normal switchgear would work. Whether if you compare it with, let's say, conventional GIS, there's no change in terms of overall life cycle of the product and overall serviceability of the product, right? I would also try to bring about a point where you spoke about usage of sensors. So I would also try to touch that point as well, because it is once we develop this particular product as something which is much more environmental friendly, at the same time compact and be innovative, it was also important to how you can make this switchgear digitally compatible. So I'll also briefly touch on that subject. Sorry. Yeah. Just give me a moment. The slide seems to be a bit slow. Yeah, so we've been trying to develop, as I said, from the alternate to SF6 gas, and we have been working on it for last decade now. And thereafter, we have come to fluoroketones, and then we have come to dry air. So a lot of things we are doing, and we have installation also across the globe. Then we have this. It is also done at dielectric insulation at 1 bar, because our GIS are so designed that even if the SF6 leaks, you need not switch off the GIS. The GIS is very much capable to run at 1 bar pressure. That has been a feature of our gas insulated switchgear as whole. We also give, because GIS is a maintenance free product, but then you can also have a repair opening in case something happens, because products are always designed to handle the worst circumstances. But then yes, as a design feature, this is also available. Once we have taken the bus outside the switchgear, then we can take any intermediate panel. Now I come to the sensor topic, as it was also touched upon, that how we are bringing the sensor technology and what is how the future is going to look like. Yes, we have the sensors available which can work with a switchgear. Those are forming the basis of smart automation and control and monitoring and diagnostics feature of those switchgear. Because these days a lot of thought process is getting driven towards the idea of having preventive and predictive maintenance, or rather condition-based maintenance to be true. So one thing what we have done is replacing the conventional current and voltage transformers with current and voltage sensors. The conventional current and voltage transformers, yes, we have been using them for decades now, and they are doing their work. But there are some potential disadvantages, as CT sometimes fail because of saturation, VT sometimes fails because of error resonance, and then these are fixed to a certain ratios. What we have done here, that we have a current sensor which is based on Rogowski coil principle, and then we have a voltage sensor which is based on RVD, that is resistive voltage divider principle. Now with these sensors in place, they can very well work as the conventional current and voltage transformers. And we have also done a typical, a sort of saving analysis in terms of giving a commercial nature to it. So we have compared, a similar 14 panel board which are using sensors and a 14 panel board which are using, let's say, conventional current and voltage transformers. And over 30 years of lifetime, they end up, saving approximately 15 to 20 lakhs for a customer only for a 14 panel board, because they practically do not have any windings, so they do not have any energy loss aspect to it. That was from the sensor side, and also adding few more, I would say, components towards having the monitoring and diagnostics feature capability. So we have a gas density sensor. We have some circuit breaker and VI electrical life sensors in place. We have environmental sensors. We have temperature sensors. All these can be wired through an RS485 to our gateway, and through this we can have a visualization either on a local HMI, or we can take it to cloud. We can view through our I would say handheld devices as well. So it's important to have an innovative product, as someone said very rightly at the start, that once I could get the information from it, that once you are speaking about innovation, it has to be holistic. It has to have all the basic product features into place, and at the same time giving you much more efficient, much more maintenance free, and also a digitalized switchgear going forward into the future. So this was just the topic what I want to touch with help of this particular product. So yes, that's it from my side. Thank you so much.
Thank you, Mr. Kumar. Now I would request Mr. A.K. Rajput, the Chief Engineer R&D with Central Electricity Board, New Delhi. He will speak about the overview of the switchgear, including O&M, IoT application, indigenization, testing and automation, and competitiveness. In brief, Mr. Rajput is an MTech in power system from IIT Delhi. He has over 32 years of academic and professional experiences in Indian power sector, covering the experience in the field of thermal power generation station, operation and maintenance, planning and development of distribution network with added focus on reliability of power supply and loss reduction in distribution system, formulation of the national electricity policy, national tariff policy, rural electrification policy, in brief. So over to Mr. Rajput.
एक मिनट आना है. Just I am trying to share. Thanks. First of all, thanks again. So I think the computer is slow, and I am trying to share whatever PPT I have prepared. Hopefully it will connect. Give me a minute.
And sir, we are short of time, so if you can briefly make the presentation, that would be helpful.
Of course, I will keep in mind the time factor. Of course, the presentation is big, but I will increase my speed and summarize. First of all, this switchgear, as has been told, this is the presentation mode. I hope
Not-
it is clear now.
Yes.
So basically, we have the electrical power system and switchgear is an integral part of it. Without switchgear, we cannot think of that the electricity supply system will work. Either it is at the generating station or right up to the your household supply or even a very small pawn shop supply. So everywhere the switchgear is there in one form or the other. We start with the fuses. The journey started with the fuses when the electricity quantum of the electricity to be handled was very low, and that worked fine. But as the demand increases and the requirement increases, the technology came and the so many technologies emerged, as has been told, say from oil circuit breaker now to the pure air based circuit breaker with regard to the environmental friendly aspects. So design of the switchgear has to ensure that it will be able to detect abnormal or undesirable conditions in the circuit and then trip the circuit to disconnect the affected area without affecting the other healthy areas. It is basically known as the discrimination, and this discriminatory feature is a prevalent criteria or the paramount criteria for the design of the circuit breaker or the switchgear. And next slide. It is not coming. So how it evolved? The simplet start with the fuse, but fuse has the limitation. It needed a time to replace it. Till that time, the power supply will remain interrupted. That is the limitation with the fuse type of the circuit breaker. So what are the essential features of the switchgear? When we select the switchgear or any product for use, we select. So by selecting the switchgear, we have to see that it is selectivity. It has got the selectivity feature. It is precise in operation. It is reliable, fast enough or swift enough, and safe to operate. As I told in my opening remark also, that while operating, sometimes they burst and they create havoc, even the fatal accidents also. So we should avoid, and we should have a proper design review and the simulation testing before deploying them in the field. And even prior to deploying in the field, they have to pass on several type of the tests. Those include the type test as well as the routine test at the factory. Design, construction and layout should be as simple as possible. This is very much important for any type of the machine or any type of the installation. Then availability of the spares have to be ensured. There may be chances that the product is going to obsolete. That has been dumped to the utility at a very lower price. But later on, the product has become obsolete and its spares are not available. So ultimately, it will be a very costly affair. And downtime will also be there. Operation and maintenance should be safe, simple, and less time consuming without being the economical also. It should not require that only the experts from the OEM will come and he will be maintained. The trained personnel of the utility should be able to maintain and replace the switchgears when it is demanded. Another features are that whatsoever the products are there, suppose say trolley-based switchgears are there, trolley-based circuit breakers are there, they should be interchangeable for the same type of the rating. I'm not saying that for the high type of the rating or other rating, for the same type of the rating, at least they should be interchangeable. It should not emit any harmful emissions. Lot of emphasis has been given by all the respective presenters. The product parts should be easily recyclable in an environmental friendly. I have gone one step ahead. That is, the harmful emissions should not be there during the operating time. And where it completes the life, at the end of the life, if it has to be recycled, it should be recyclable. And some useful material, some useful metal should be reclaimed out of this. That proves to be an economical solution. Fault conditions must be quickly diagnosed and isolated with confirmation. It should give an indication also that the fault has been cleared and here is the indication, or here is the signal going to the control room in an affirmative way and in a confirmative way. In case of the failure of control circuitry or control power supply, the switchgear should have the facility of the manual operation also. Sometimes the power supply control power supply from the batteries do fail or the cable gets cut. So there should be a provision of manual operation of the circuit breakers from the local or from the remote, both. So there are various types of the classification. One is the air insulated switchgear. Of course, it is up to say 36 kV or 33 kV system, nominal voltage 36 kV. And then it requires somewhat higher space. But when the technology was not there, we were to do with that only. Then came the GIS. It offers the compactness and the space requirement got reduced. Of course, the cost became slightly higher as compared to the AIS. But the savings to the utility occurred in the form of the lesser requirement of the space. Then hybrid gas insulated switchgear, my presenter just before me, he has presented very nicely. The hybrid softwares are also there. Solid insulation bus bar and all those things. So let me not repeat it. And other type of the classification include oil, vacuum and carbon dioxide based or air-filled, compressed air-based switchgears. Based on the construction also, whether we are installing the outdoor installations, actually the terms are self-explanatory, so I am not going to repeat and read all those things. So whether it is the installation is outdoor, so we will call it the outdoor type of this installation or the outdoor type of the switchgear, and the indoor type housed inside the building. Both have their advantages and disadvantages. Plus and minus are there, and accordingly the cost varies. Voltage level we call the low voltage, medium voltage and the high voltage. So that is the classification based on the voltage. So what the switchgear in general do, they perform the normal on-off switching operation. They are able to handle the short circuit current and they interrupt the short circuit current in the well-defined time interval, and the time sequence of operations are also there. Sometimes the auto reclosure feature is also built in the protective devices, and after say 1 or 2 attempts of the auto reclosing, the circuit breaker should go to the lockout condition. Otherwise, the fire incidences may occur and more damage to the system can occur rather than saving it. Switching of the capacitive currents, it's some slightly highly demanding duty, and similarly switching of the inductive currents, and some special applications are also there. So where the circuit breakers are to be used and designed accordingly as per the specification prepared by the utility and accepted by the manufacturers. So these are the comparison. I will intentionally miss this, leave this table, and it is basically the comparison as regard to the space, reliability, installation cost, whether it could be expanded or not, environmental condition and the construction cost. So naturally each and every having its own advantage, and one time when they came into being, when they emerged, they were the best, and afterward more best came and they became the second one, like that. So as regard to the maintenance of the switch gears, these are the general things which is done for any of the machine, and now condition based and predictive maintenance have been emphasized and they are really needed. So at least perform the regular inspections when it is in service. So that is one more thing, that not many things comes out of experience. The experienced technicians can judge whether the machine or the circuit breaker is behaving in a normal manner or something abnormal he may observe. And then manual operation should be tried whenever the opportunity arises, a fault has taken place, and there is an opportunity, so it should be taken to the service position if it is trolley mounted, and not service, the test position, and in the test position it should be tried manually. And when there are long shutdown opportunities are there, each and every type operation, each and every parts, whether it is moving freely or not, so whether it is stuck up somewhere or whether it is making noise also, or if say some mechanism or some link is there, whether the link is weak, so those things can be investigated. Overall, the OEM's instruction had to be followed because he has done the proper design and proper inspection of this, and he has the feedback from all the users around the world, and that's how he has prepared the instruction manuals, O&M instruction manual. And one more thing is that only authorized and trained personnel be deputed for carrying out the maintenance. Otherwise, instead of carrying out the maintenance, he will do something else that will be dangerous to the machine as well as to himself and as well as to other personnel working around. So in the maintenance cell, you will be doing the lubricating, primary and secondary disconnection, racking mechanism, and the interlocks you will check whether they are functioning or not. Overcurrent protective device will be tested, insulation testing will be done, spring charging mechanism, closing and trip circuit testing will be done, whether they are continuous or not, and they are getting healthy supply or not. The fuses will also be checked properly. So these are the things. So Internet of Things and the modern type of the switch gears, it is basically demand of the time. And as the complexities in the system are increasing, it is basically the age of data, how the data is collected, how the data is transmitted, and how it is analyzed based on the computer programs and other diagnostic techniques. So that is all the basis of the IoT applications in the switch gears. Of course, my previous speakers have told a lot many things and lot many intricacies about the IoT, how it will be functioning. But when we talk of the IoT and switchgear, supervisory control and data acquisition based systems, we have to be very careful about the cyber security aspects also. Otherwise, somebody may hack and that hacker may do enough damage. So these are the advantages of the IoT switch gears. These are the smart functions, and electricity can be managed in a smartly and effective way. It gives the flexibility of the operation, and moreover, it is basically quick and it helps in decision making. So whatsoever our 100 smart cities hypothesis is there, and that initiatives are there of the government, the requirement of the smart type of the switchgear or the IoT based switchgear will increase. So that is the effect on the markets. So then in this series come the digital substations and its features. Digital substations incorporate intelligent electronic devices, that is IEDs. It is basically the higher form of the relays and all those things combined into the one integrated unit, which is communicable also. Of course, with integrated information and communication technology, non-conventional instrument transformer like say optical CT and optical PTs, which are not having say so much damages and not getting affected because of the electrical surges. So those units provide better measurement and the metering parameters, merge units, and also the phasor measurement units. So phasor measurement units also measure the phase. Generally we measure the voltage, current, and the frequency or the power factor. And this also phasor measurement units measure the phase of the phase angle also, and it helps in better diagnosis of the fault conditions. And also we can predict that how much is going to be the system when we are talking of the real-time operation of the system. So it completely eliminates the need of the switchyard panel rooms, thus significantly reducing the project commissioning time. It permits remote administration, that is the remote operation. It helps in independently regulating voltage through smart transformers, improved productivity and functionality, greater asset reliability, and substation operator safety are also ensured. So what are the growth drivers in the market? Large scale RE integration is one. Confluence of industry and information is taking place. Lot of building construction activities is taking place, and the large buildings naturally have the 11 kV particularly and the low voltage switchgears requirement. So those will increase the demand. Those will be helpful in creating the market sustainability. Our switchgear industry, it is learned from the sources of IMA and other professionals that they are having the overcapacity. The orders are not with them, and some of them are running only at say 60 to 70% of the duty cycle. So that situation is not good if they are becoming the standard assets for the investors. So market demand should increase, and market demand will increase because of these reasons which I have just narrated. And there will also come a time to replace the existing switch gears which are going to outlive their life. So they need to be replaced with the latest quality and the latest version of the technology. So that demand will also come. And RDSS is one scheme which Additional Secretary also mentioned, revamped distribution system schemes. So lot of scope is there for all type of the electrical equipment manufacturers, including the switchgear. And RDSS will be particularly catering to the medium voltage, that is up to 33 kV, and down below systems. And for evacuation of the large amount of power from the remotely located renewable sources of energy, the extension of HVDC and HVAC transmission line is taking place. So there, in that particular segment, the high voltage switchgear will be in demand. CA has also done as its duty. CA has published the guidelines for availability of the spares, that how much should be maintained. So that attempt has been made, of course, with the consultation and the level of participation from the different stakeholders, including the industry and the utilities. CA has also issued general guidelines for 765 and say up to 132 kV substation and switchyard of the thermal and hydropower plant. Switchyard is associated with each thermal and hydropower plant. So for those switchyard, some general guidelines have also been made. And in addition to that, to facilitate and streamline and bring a discipline in the system, CA has published, CA has not published, should not say published, CA has brought out as a part of the statutory requirement the regulations which are binding to all. And those are necessarily provide a visionary step and the facilitative steps, this one. Then SF6 we have talked. Now it's my duty to tell you that in place of this 1 kg of SF6, equivalent to 23,500 times of the global warming potential of 1 kg of CO2. This figure has now been updated by UNFCCC, and now this figure is 25,200. So the world is very serious. European and the American world is more serious about this SF6 replacement, and up to certain voltage, because suddenly a jerk cannot be given, and if the technology is not existing, how the things could be installed. So 765 kV and 400 kV systems. These alternative gases at present are not available, but up to say 145 kV, there are rulings that in a phased manner after this particular date, no more SF6 based case, SF6 based switchgear up to say 145 kV level. 245 kV voltage level switchgears are under the testing stage. Design has been completed. They are in the testing phase. And as far as gas insulated lines are concerned, 400 kV SF6 based or the gas insulated lines are in service, and there also the whatsoever the alternative gases are there, they can also be utilized in those gas insulated lines. So there are 2-3 types of the development which just ABB has also showed. ABB expert has just shown. So switchgear devices having vacuum chamber interrupter surrounded by non-SF6 gas enclosures, that is the compressed air, pure compressed air, and he rightly mentioned that it should be the dry air. It should not contain moisture. So that adds a cost to it, making the air completely dry. Most prominent among that is, of course, it is a, I'm taking some trade name, G3 gas. It is a mixture of some non-toxic and non-flammable gases, and manufactured by as a proprietary item by 1 or 2 manufacturers. So this has about 1/6 of the global warming potentials. So and we should not remain satisfied even with this also, that we use the G3 gas and become happy because it is happy 1/6 of the global warming potential, because the figure still would be high. Say if it is 24,000, it will be 4,000 times than 1 kg of the CO2. That is also sizable and should be kept in mind. 145 kV and 245 kV I have told. 725 kV many installations are there in the offshore wind installations. These type of the developments are taking place. This up to 245 kV, I can skip it. And global switchgear market has been told by my friends here. So one of the sources say that it, by 2025 it will be $88.5 billion market, US dollar. And pre-COVID, post-COVID-19, CAGR is 5.5% has been observed. And when the situation improves, the growth is likely to come up. So there are a lot of opportunities, and everybody wants to provide the hassle-free electricity. And biggest advantage of these gas-based switchgears is that they are almost called as the maintenance-free. So several government bodies, that is the state regulatory commissions, they have added reliability as a component in the revenue generation stream of the state discoms. That is, by that, in a simple term, if I say that there should be standards of performance laid down, and those laid down standards of performance have to be complied with by the respective discoms. So naturally, the discoms will go for underground cabling wherever possible, the aerial bunched cabling instead of overhead LT lines, because they are more prone to the fault, and also to the advanced quality of the switchgears, which give lesser trouble and are more precise and more robust in their working. So government has also set a goal that we will be achieving the Atmanirbhar Bharat, and through Atmanirbhar Bharat Abhiyan or the Self-Reliant India, Make in India initiatives have been taken in various directions. And as additionally secretaries are told that the manufacturing zones are being set up, and further phased manufacturing plan, that is scheme, we are preparing. Of course, some presentation on that is there on Monday. So I will be hard pressed in my weekend also to prepare to the secretary. So on the PLI scheme for the identified electrical items, many friends from the industry, they may be knowing, and the utilities, that we have worked out and identified at least some 10 components, and the 11th component is the CRGO, cold roll grain oriented steel, that is under, we have given to the Ministry of Steel to look after, because it is their prime domain. And other 10 items, those include the switchgear components as well, and alternative gases concept as well. They will be, and the polymer insulators and the things like that, they will be in the domain of the PLI scheme of the Ministry of Power. That is information to the industry and the users. So key challenges in the switchgear market which are being faced and reported to us are that overcapacity of the switchgear manufacturing industry is there, and they are not fully utilized. Challenge is of the repeated type test. Some of the utilities do not accept the type test which has been, say, conducted recently, and they insist for the new type test. So that takes time, and that is the cost consuming also. Lack of adequate research in the field of material science is observed. That is our own analysis being in R&D. So that lightweight, good quality alternative materials may be in the form of some alloy, because now the aluminum casting is used in GIS-based insulation. So we are thinking, or we are, say, offering a challenge to our own engineering community, scientist community, that they develop some material which is equally good and more robust, and is also lightweight. Quality plans and quality checks need to be worked out, and it would come from the experience that what type of the quality plans should be there in place, and what type of the quality checks at the manufacturing stage and at the acceptance stage have to be done. Few more slides are there, don't worry.
Sir, we have 4 speakers left. So if you can...
Oh, sorry, I was thinking that there is one only.
No, there are 4 speakers. That is why.
Right, sir. Then I will not do much here and there. I will come straight to the point. Standardization is a requirement. Substation automation compliance should be there to the IEC 61850. Economy of scale will be there. Then only the dream of the self-reliant India can be realized. When the economy of scale is there, so our product will be competitive. And when the products are competitive, the end products which every consumer uses, they will also be competitive. See, because the input cost will reduce and the product will be at a lesser cost. So distances of the transportation are limited. As has been told that they have to carry their equipment either to the Bhopal in testing or to the Bangalore for testing from the from the far off places. Similarly, in the remote locations, sometimes the roads are not so good. So maybe you have to construct the special vehicles, and the parts or the switch gear which you carry, say, usually in a assembled form, in a one piece form, that may be required that it be sent in several components and be assembled at the site. So performance requirement and compliance to the regulatory provisions has to be made. Economy of scale increases the competitiveness, this I have told. Performance requirement and compliance. Oh, this slide got repeated. So way forward is increasing awareness about the benefits of the switchgear, of the new variant, the ability of the modern switchgears to avoid fire accidents and protect human life gives them an edge over the conventional method. Here again, I will, at the cost of repetition, I will say that the harmonics we have not considered while designing the switchgear and the harmonic type of the loads. So that also need to be researched basically how the harmonics will be affecting our the cable connections, relays, and the switchgear contacts parts. So green energy component, this is a new thing. Let this concept also come in the tender specifications of the utilities, that in manufacturing say particular piece of the equipment, on an average, how much green energy component has entered into it as compared to had this been manufactured by using the fossil fuel based electricity. So that should be given weightage so that our ultimate aim of carbon neutrality is achieved. Domestic value addition should be given weightage similarly in the tender. Procurement policies and bank guarantees, this procedure should be very clear. Deployment of professional, that if we call the expert that you please come and maintain our switchgear. Actually, there cases have been that the expert has to be called from the say France or Switzerland, and then only he could repair. The local MNC fellow, I will not name the company, the local MNC is not in a position to repair the GIS. So it is particularly with the GIS, it is about say 10 years back condition, but now this will not be there because now the switchgear is being manufactured in India. 400 kV as well as the 765 kV switchgears are available in India, manufactured in India. So whatsoever modifications are required, we can easily give them the feedback. They can come investigate. तो ये मेरे को कहने के लिए रह गया था, धन्यवाद।
Thank you, sir.
So my journey stop here, and I have got a phone call also. Please permit me to attend that.
Yeah, okay. Thank you very much.
Thank you,
Now
sir.
I will request a small presentation from the CMC. I would request to make the presentation very short for 3 to 4 minutes because we are 1 hour almost behind schedule. And after that, the system will not permit us to continue. So that is my earnest request that if you can make the presentation short.
So can you hear me? Hello?
Yes.
Okay. Good evening, everyone. I'll keep it as short as possible. Actually, we are supplying or catering our products to the switchgear industry. We do not manufacture switchgear, any sorts of breakers or anything ourselves, but we do it. We do supply parts to the other companies, and we are also ISO 9150 2015 certified company. I'll just run past all these. So our vision was to be an efficient and competitive sheet metal fabricator, and also a CNC manufacturing, CNC machining component and busbar manufacturer. So we started in 1967 in Kolkata, and since then we have got approvals from RDSO, and we started developing VI components in 2006. And since then we have been associated with Schneider Electric and other companies. We are located in Gujarat as well as in West Bengal. We started off our Gujarat plant very recently in 2019. So a few of our we use all our machines are CNCs. We do not we have conventional also, that is our tool room. But other than that, we cater to all sheet metal components and copper and aluminum and brass components. So this is our facility in Calcutta as well as in Baroda, and we very much concentrate on the quality of products which we supply to our customers. We also have our in-house plating plants both in Calcutta and in Baroda, where we are into plating tin on aluminum and copper as well as silver. And in Calcutta, we have our lead plating plant also. So this is the market segment which we cater to: the switchgear and control panel, transformer industry, the machine manufacturers, railway segment, textile segment, industrial battery, automobile sector, and the defense sector. These are some of the products. For example, this is an entirely fabricated panel which we have made in our Baroda plant, including the transformer and the RMU and the LV unit. These are the bus bars which are required in the switchgear industries. These are some of the critical items which are required in the transformers and also the switchgear industries. So what we try to do is give our customers a very good quality material which is error free in nature at a very competitive price. By with that, it becomes easier for our customers to make the products error free, and that increases the productivity on our part as well as on our customers' part. And with the increase in the switchgear industry, we hope to cater to as many people as possible. And as Sir said, Atmanirbhar Bharat is targeting to make products more indigenous, and that is another place where we would like to come in and help all the other switchgear companies, to make their products in India, and not to so that they do not have to wait for replacement parts or anything. So saying that, we believe in teamwork, and so thank you so much. Thank you.
Yeah, thank you very much. Now I will invite Mr. Anjan Banerjee. He will speak on the digital solution within HV switchgear for smart management of assets. Mr. Anjan Banerjee is having 26 years of experience in power transmission and distribution domain. And Mr. Banerjee is presently heading the digital and green solution within high voltage switchgear at GE T&D India Limited. Over to Mr. Banerjee. You are not audible. I think you are mute.
Hello. Good evening. Hello.
Yeah, good.
Yeah, is the slide visible, Mr. Chattopadhyay? Hello.
Yeah, yes, it is visible. Please continue.
Yeah, very good evening, respected ladies and gentlemen. I am Anjan Banerjee. I am taking care of digital and high voltage solutions within digital and green solutions within high voltage at GE T&D India Limited. In the next 15 minutes, I'm going to, sorry, there is some problem. Yeah, in the next 15 minutes, I'm going to cover a brief overview of the products and solutions being offered by GE T&D India Limited. And then I'm going to present the digital solutions that can be offered within high voltage switchgear for effective management of these assets. As we are aware, GE T&D India Limited is present in our country for more than 100 years with wide range of products and solutions serving our customer. These solutions and products include high voltage switchgears covering both air insulated as well as gas insulated, power transformers, grid automation in the form of substation product protection, substation automation, substation communication equipment, software solutions for energy management system, distribution management system, turnkey substation design, supply of equipment and construction of AC substation, high voltage DC substation, and flexible AC transmission systems. All these products and solutions are backed up by strong field service team. We do have comprehensive solutions for asset optimization and asset management. GE T&D Limited is a leading. Hello? I'm sorry. GE T&D Limited is a leading player in high voltage switchgear space. We have two state-of-the-art factories, one at Padappai in Tamil Nadu, where we are manufacturing high voltage switchgear from 72.5 kV up to 765 kV, and gas insulated switchgear from 72.5 kV up to 800 kV. In the manufacturing unit at Hosur, we manufacture high voltage current transformers up to 800 kV, voltage transformers up to 1200 kV, line traps up to 800 kV, and current transformer for gas insulated switchgears. Now let us turn our attention to the digital solutions that we offer for effective management of the switchgears that I explained in the previous slide. Before I mention the features of the digital solutions that we offer, let us first try to understand why do we need digital solutions for online monitoring. We first take the example of circuit breaker. We are all aware circuit breaker is one of the most critical piece of equipment in power system network. Say for example, we have a fault in the equipment. Even though the protection relay has sensed the fault and given a command to the circuit breaker to operate, however, the circuit breaker has not been taken care of properly and it has failed to operate or cooperate. The result would be initiation of busbar protection scheme and unintentional tripping of base. So proper care of circuit breaker is required to mitigate this severe consequence by implementing online monitoring solution of circuit breaker, which would help us in condition-based monitoring. Another important part is circuit breaker is one of the most dynamic piece of equipment where the contacts are traveling in milliseconds. We have arcing current during fault interruption, Sf6 pumped in to extinguish the arc. That means the circuit breaker components need regular maintenance, not time-based, but condition-based. As because if we have a condition-based maintenance with online monitoring equipment, we would be able to identify which component is faulty, and by replacing that component, we would be able to extend the operating life of circuit breaker reliably. Last but not the least, we have heard circuit breaker uses Sf6 as the insulation and the arc quenching medium. Sf6 is one of the most powerful greenhouse gas known to humanity. So we need online monitoring tool which would be able to track the Sf6 leakage in the atmosphere and would be able to minimize Sf6 leakage in the atmosphere. When it comes to gas insulated switchgear, I would like to share a statistics which is available in one of the SIGRE publication. This publication documents the root cause of failure of GIS, and we will find that particles, moving particles, protrusion in HV conductor, void in insulator, they are the source of partial discharge within GIS before an electrical flashover occurs. Because of this discharge activity within GIS, there is continuous contamination and decomposition happening of Sf6. So partial discharge activity must be monitored within GIS on a real-time basis. And an online monitoring solution can help us to monitor a partial discharge activity within a GIS compartment. Now, when we talk about online monitoring or digital solution, we also have to make the switchgear smart enough by embedding intelligent digital sensors within it. Say, for example, when we see here over here in circuit breaker, we need to offer digital sensors for Sf6 gas temperature and pressure measurement. We also need to offer sensors for motor coil current measurement, position sensor to monitor the contact travel of the circuit breaker. In case of GIS, over and above all the sensors I mentioned just now, we also need to offer ultra high frequency antenna at various strategic locations of GIS, as this antenna captures the ultra high frequency signal originating during partial discharge, which we will see in the subsequent slide. Now let us come to the intelligent electronic device that we offer. We have GIS Watch, a comprehensive online digital solution for gas insulated switchgear, which can continuously monitor any partial discharge activity within GIS. Over and above, the solution also monitors Sf6 gas temperature, pressure, and density within the GIS compartment. For circuit breaker, we have a digital intelligent electronic device which is known as CB Watch. This CB Watch can monitor each and every critical component of circuit breaker, as we will see in the subsequent slide. So let us come and see what are the features offered by CB Watch. CB Watch, as I said, monitors each and every critical component of circuit breaker, starting with gas leakage. So the device captures pressure and temperature from the sensor that is fitted in the circuit breaker. And from pressure and temperature, the device computes density, and any change in density would be construed as a leakage happening from the circuit breaker compartment. Not only that, the device can predict what could be the density of the circuit breaker Sf6 gas, say, for example, 90 days down the line. And by forecasting, and if the device estimates that the density would go below the first level or the second level within the next 90 days, it would alarm the user in advance so that the user can plan resources like testing equipment, manpower in a planned way, so that the circuit breaker maintenance can be taken up in a disciplined way. Apart from that, the device also captures the interrupting current and the arcing time and computes arcing energy, which is nothing but square of the interrupting current multiplied by the arcing time. And by integrating this arcing energy, the device would be able to estimate what is the cumulative electric wear of the circuit breaker contact. And if the value exceeds the threshold, the device would generate an alarm. Another beautiful feature of this device is the device can compute what is the travel time of the circuit breaker contact and the speed of the circuit breaker contact. This can be done in two ways. The best way is to mount a position sensor in the mechanism. In that case, the travel time and the speed can be computed precisely. Over and above, the device can also plot the travel curve of the circuit breaker contact, as you can see over here. If, say, for example, position sensor is not available, the device would compute the travel time or the speed from the auxiliary contact of the circuit breaker. Next, the device also computes the spring charging time. If the spring charging time is too high or too low, both are problematic, and that would point out that there is a problem either in the spring or in the motor of the circuit breaker. Further, the device also monitors the health of the closing coil and the tripping coil by monitoring the coil current. The device also supervises whether there is any issue with the trip circuit integrity. And if there is any trip circuit opening, the device would generate an alarm. So that means we see that each and every component of the circuit breaker are being monitored by this intelligent electronic device known as CB Watch offered by GE. The device is very compact. As you can see over here, It's available in DIN rail mounting and can be mounted either in the circuit breaker mechanism or in the low voltage control cabinet. And then along with the device, we also offer an expert software. This expert software analyzes the risk of every element, and depending upon the analysis, it would attach a risk level index. Say, for example, as we can see over here, in this particular case, the circuit breaker Sf6 gas level density has gone below threshold 2. So then the device would alert the user with a risk index of 5. That means the circuit breaker can no more be continued in service. It has to be taken for maintenance. So this is actually a truly condition-based maintenance solution offered by GE to customer. Now we will have a look at the online monitoring solution for GIS, which is known as G-Swatch. We discussed a few slides back that the challenging scenario in case of GIS is a partial discharge activity. So let us see how a partial discharge activity can be detected by an intelligent electronic device. When we have a partial discharge, which is basically because of say moving particle, as we can see over here, this moving particle would create a partial discharge current path, and then we'll have an ultra high frequency electromagnetic wave generated. These ultra high frequency electromagnetic wave are captured by various antenna which are located at the various strategic locations of GIS, as we can see over here. Over and above, we also provide external antenna because there could be ultra high frequency signals originated due to noisy environment in the substation. These ultra high frequency antenna are connected to the intelligent electronic devices which are acquiring this UHF signal and doing the analysis and determining whether it is a genuine partial discharge event or it's a noise. There is a robust algorithm available within the system to discriminate between an ultra high frequency signal originated due to noise and an ultra high frequency signal generated due to partial discharge. So as we can see over here, there is a narrowband frequency spectrum analysis available in the system. Now this system is always commissioned because before the GIS is energized. This system is always commissioned before the GIS is energized. Why we do that? Because at that point of time, there would be noise in the environment, which would be captured by the external antenna located in the GIS. And the system will capture these signals, and those signals would be masked. Like those are the frequencies which are attached to noise. So now when the GIS is commissioned and in service, say for example, we have kind of a challenge and we have some kind of a disturbance within high frequency disturbance. So those high frequencies which are outside the mask will be captured as a potential partial discharge activity. And those high frequency disturbances will then be analyzed in a time domain, what we called a phase resolved pattern analysis. Now, what we do in a phase resolved pattern analysis is that the signature of the partial discharge which is basically analyzed in a time domain would actually correspond to a particular defect within the GIS. Say, for example, when we look at this particular signature of partial discharge, where the signals are concentrated more towards the peak of the positive wave, that means there is a protrusion in the HV conductor. And if the signals are diffused in the positive half of the wave, that means this partial discharge is originated from the moving particle. So these kind of analysis are available, and it would help the user to readily pinpoint where the problem is, and the problem can be addressed without much of shutdown requirement.
Mr. Banerjee, can you be slightly brief?
Absolutely. So now over and above, we have other information like a single line diagram, which will throw all the data related to the gas density, pressure, temperature, as we can see over here. And also it will throw the severity of the situation. If it is a situation where the Sf6 gas density is below the second level threshold, it would be indicated with a rate code, and the values also will be indicated. We'll also know what is the leakage rate happening at any point of time of Sf6 into the atmosphere. So basically, to summarize, if we have this kind of a digital asset management, we will be able to develop a smarter asset management and replacement strategy, as all our decisions and facts will be backed up by data. We will be able to optimize maintenance with advanced warning. We'll be able to build a green substation, as we can track and minimize SF6 leakage within the atmosphere. And last but not the least, we are investing so much of amount in substation automation system. At the moment, not much of assets data are going to substation automation. So with these digital solutions, we will be able to seamlessly integrate asset data into substation automation system and also to LDC, so that prompt action can be taken on asset management and asset replacement. Thank you. This is all I have for the day. I'd be open for any questions on this topic.
Yeah, thank you very much, Mr. Banerjee. In fact, we are really out of time schedule. So we'll have a small video presentation from the Plastofab India Limited, and then we'll have last speaker, Mr. Abhijit Makar. So, Shima, please.
Controlling power by Plastofab. Electric power control deals with routing electric power. Controlling is quality and controlling the devices attached to a power line. A number of electrical technologies have evolved for using the power wiring to turn devices attached to the power line on and off, monitoring attached devices and similar activities. Collective efforts are taken by Plastofab for power utilities sector to serve break-free products. The first leading role in this epoxy resin cast, FRP test terminal system, auxiliary switches, bus bar support, motor terminal blocks for new technology in the switchgear, LT, and HT field. All necessary tools are being designed and manufactured through power shape and power operatives through CNC machines using special grade of steel. It's to meet specifically an experienced cadre of professionals from diverse disciplines, plus customers on the basis of FMEA, failure mode. For 310, Allmans are a comprehensive package of specialized options, including from acting as a solution provider to solve customers' application problem, of product and supply to end customer as per desired needs. Products tested at Plastofab laboratory ensure reliable and safe operations at site, as well as specific requirements as per resins particular needed to fab manufacturing system is estimated. Plastofab's commitment to power supply quality continues with rigorous post-manufacturing testing sequences, each as per customer system application deserved. Checking on resin casting products as per statutory norms. X-ray imaging also carried out in addition to special check the quality of void-free casting, as well as national or international statutory norms as specified. People mentioned as the leading globally diverse and exciting workplace by working together with a dedication reflected in your quality products and industry reputation for performance in your quality. Crompton Greaves, LNT, GE Alstom, Andrew Yule, Bicolori, Electrotechnica, CESE Kolkata, Toshiba, Stelmec, SM Royal, DHEL and various OEMs, WBSE DCL, Pascal Switchgear, Emco, Voltam, Bharat Bijli, RPG Breakham, Schneider, etc. Schneider. New administrative offices are designed to offer expanded engineering, technology, sales or marketing, account and manufacturing in India, specifically Kolkata and Nasik. Facilities, Energy Star rated appliances and are Environment Protection Act certified. Plus flow junction with various equipment such as switchgears, transformers and allied products for the transmission and distribution of electrical power to both industry and domestic field within the society. With full respect to electrical and teamwork. Diversity and unity brings creativity and relationship within the company and to customers. In tech industry and the explicit market needs in a responsive supply chain. Bus bar spout, circuit breaker drive insulator, interrupter housing, support insulator etc. for switchgear application up to 33 kV. Data etc. Auxiliary services, motor cutoff switches, test block, test terminal block etc. Employee recognition and encouragement through special prizes etc. for new invention or attendance or commitment towards job quality. Participations in various social activities through financial donation or assistances. For example, book donation to socially needed students. Controlling with the power, now and forever.
Thank you very much. Thanks to Plus2Fab. Now I will invite our last speaker, Mr. Avijit Makur. Mr. Makur is the Additional Chief Engineer, West Bengal ACDCL. And to give an introduction, Mr. Makur is posted as a Distribution Testing Department of WBACDCL as a Additional Chief Engineer. He has been associated with the various substations during his service as Operation cum Maintenance Engineer in Lilua, Howrah, Jirat, Arambagh, and he was associated with the construction of 132 Coach Bihar and Nagraghat 66 kV substation and its commissioning. Over to Mr. Makur.
Yes. Presentation, please.
Yes, sir.
Presentation, PPT.
Yes, sir. Just a minute. Presenting, sir.
Yeah, well, an overview of switchgear and history and applications. Please proceed. Next. WBC DCL is a state utility. Next. We purchase and generates power and distribute throughout the state of West Bengal, including utilizing its infrastructure and subsequent service customers to earn revenue. The mission is to give uninterrupted power and quality supply to all, and for that, accurate measurements of power as vital electrical parameters are required. So, for reliable energy audit and accounting and billing purposes. Next. The circuit breakers, basically, we have, if we divide them as a coaching medium, there are 4 types: air blast, oil circuit breaker, Sf6, and vacuum. Next. Yes, sir. Next. But in terms of services, you can either use indoor switchgear or outdoor switchgear. Next. You can classify it as in the term as per the operating mechanisms. Either it's we have a spring operated circuit breaker, hydraulic operator, pneumatic, and sometimes there is a combination of two. Hydraulic and spring operated is the pneumatic or spring house is the that is commercial now in service. Air blast circuit breaker is the one that has been often discussed by earlier panels. I don't want to go into it. Go next one. The air blast have actually good performance and has a high maintenance cost, because even if there is a problem, you need to take it a shutdown and attend the leakages, as the prolonged shutdown is not available as far as the as system conditions. So this has presently become obsolete. Next. Air circuit breaker is in there, low voltage switch gears. Yes. Next. Next. Bulk all circuit breaker and minimum all circuit breaker are in service. in old substations, but nowadays they are no more in use. We are phasing out, and other utilities have also phased it out because of its high maintenance cost and its availability of spares. Next, next, next. MOCV is complete. Sf6 circuit breaker is and vacuum are the two circuit breakers that are presently in service most of the utilities and consumers levels. But this Sf6 gas being a greenhouse gas, as other panelists have discussed, is supposed to phase out, and some international regulations will come in due course, as it is harms the environment. And however, vacuum circuit breakers up to level 132 kV are uh, are there in service, and maintenance is also cost is very less. So this is the one that is presently is preferred form of circuit breakers in most of the utilities and the consumers. Next, 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 next. A hybrid switchgear. Now, since the space requirement for AIS substation is very large, and that is not available at present. So gradually we have shifted from AI substations to hybrid switchgear, wherein isolator, CTs as well as the switchgear is in a one capsule. We require at least much less space as than the in normal conventional switchgears. And wherever in the old substations we require to extend extend number of bays because of increased load demand. So this is the most preferred form that is form used by the utilities at present. Next, next. The GIS substations have been now in vogue as land has been very costly, especially in the metros. If you want to oh, AI substation, the amount of land required is simply not possible to acquire. So we have since the technology has found GIS substations is now used in by all utilities from 400 kV up to 400 kV substations, and the size in a you can use a GIS substation in the rooftop. So the space is not a criteria. Even if you have if you own a building, then you can use it in down. One floor can be used for a switchgear, and the remaining floor can be used for any commercial apartments. So that is the way we are we are moving ahead. Next, next. Intelligent switchgear is the form of switchgear that we had now. So is earlier all the switchgears that we had, where they had a separate module for switchgear, separate module for protection and sensing equipments, and then there is a relay module which combined and for protection features. So these separate modules did not have any communication module, and uh, but as we move ahead, this without the communication module, presently it is not possible to maintain the system as it is. The days as we go ahead, the number of consumers that we are required to feed from the same sources has increased, and there are some issues in every case instances, and you need to have a communication between each and each module so that in case of any issue that can be analyzed and located. Uh, uh, Before we require reliable power for 24 by 7, and at the same time we require the quality power. So any a fault within the circuit breaker or the metering circuit or the what do you call the sensing equipment CTs PTs, if there is a detected before the actual fault is initiated, that is that gives a time for us to go in for the maintenance and then divert the power for the shutdown period and get the circuit back into system without the consumers being affected. So this is now the essence that we require. Next, in next, 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 next. The intelligence in the switchgear industry is evolving at a rapid pace. Continuous development in infrastructure and production facilities, they can play a significant role in the distribution, electricity, and industry as well as residential areas. Adoption of smart power distribution products like smart grid is essential to introduce improved performance, continuity of power, optimize of resources available to reduce transmission, operation, as well as maintenance costs. Smart switchgear takes protection, monitoring, and control to the next level, leading to improved efficiency of the installation in which they are deployed. Next. Comparatively, the onset of digitalization has enhanced the reliability of LV and MV switchgear by manifold, and also the compatibility with other products in the loop optimizes the entire electrical ecosystem. Under the cloud-based IoT operating system, access to the valuable information, real-time monitoring, and recording of events are no more challenging tasks. With such vital information available at a click of where customers can timely plan and preventive maintenance of advanced switchgears. Even if something goes wrong, it is easier for the maintenance team to find out the causes of the fault with complete details with like on and what date that has occurred. Next. Converting conventional to modern. It is not possible for utilities or any customer to entirely replace all existing switchgear with a smart switchgear in one go. So the but digital transformers is now not a very costly affair because we require to replace some modules with a wide range of advanced retrofit solution. Necessary changes in panels, bus bars can take place, and old products and new compatible ones that come with the digital platform of data communication. Once the system is updated, all advanced communication features can be availed with same ease, thereby enabling smart power distribution with centralized monitoring out of the old switchgear panel. Next. Low voltage and medium switchgears are embedded with safety features that protect the system from various circular overloads, short circuit, ground faults, under voltage, single phasing, and motor related faults. These switchgears are effective in preventing fire and various other electrical accidents because they immediately disconnect the faulty system. Safe for human as they measure the leakage current or partial discharge. Monitoring and control features are being incorporated can be done at a minimum possible time. Next. The big IoT cloud-based management, centralized monitoring and controls through the internet are going to boost the industry in a big way. Smart and intelligent power distribution and energy monitoring solutions is the future. Smart power-based switchgears that offer advanced protection and high-end energy monitoring system can communicate with the local PC as well as web-based network to monitor plant machine performance and energy consumption status. That these devices can communicate with PLCs over a communication network and can be monitored and controlled through internet-based devices. Features like fault records, quick identification of specific cause of trouble can and minimize the industrial breakdown time drastically, thereby improving the performance efficiency and efficiency. Next. Now, power system stability, I think I want to skip this one as the time is short. The only one thing I want to say is that let's go to the previous slide. Just previous slide. The fault clearing time. Fault clearing time is one part that is very important. And if the fault clearing time is not within a certain, then the generation can go out of step because the um, we have most of the generators that we use are um, uh, alternators have a DC magnetizing excitation and the outside order that is a so if there is a the angle torque angle delta increases of a certain limit, then the system will go out of step. Next. This is the calculations I have done, but since the time is short, I will skip through it. Next, next, next. See, delay in fault. What is the delay in fault will render stability of system because fault occurrence clearance time depends on the relay, operating relay sensing time, operating relay actuation time, master trip sensing plus actuation time, then circuit breaker trip coil actuation time and physical separation contacts. The total procedure requires 10 to 120 milliseconds. Even in a very conservative estimate, it does not take less than 80 milliseconds because each and every part has its own transient response and that adds up to the delay. Next, the response of short circuit for interruption of load or healthy circuit for more a function of a switch gear. So as this is the same discuss. So go ahead. Next, 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 next. The brief history of the utility of why at all the smart switchgear has come into board. As per Indian contest on 30th July 2012, a blackout affected over 400 million people. Uh, and briefly the largest power outage in the history by number of people affected, beating the January 2000 blackout in northern India by 230 million. The blackout on 31st July is the largest power outage in history. The 22 states in India was plunged into darkness due to failure of northern grid triggered by overdraw of tie line on account of grid failure. And next, all the grids were connected through a synchronous link, uh, while the southern grid is connected with the asynchronous. This was delivered in for safety of the system. The Indian power grid actually designed with 5 grids: northern, western, eastern, southern, eastern, northeastern, and southern. If southern grid and the other grids are connected by asynchronous links, so when this power fault occurred, the all other except southern grid, everyone went into darkness, and in the eastern grid, CSC somehow isolated itself and was saved. So this led people to think that something has to be done, as a conventional protection system is not sufficient for us to maintain such a large power system. And this integrated this is what sent heads rolling, and a special committee was formed, a protection committee, who visited every substation of importance and collected data of regarding the protection system involved. Next, this protection system and demand concept of demand management came into being. The frequency is one of the is a one component in the power system that is actually monitored. Uh, and this whenever if a frequency drops a certain level, then the generator goes out of step. So in case of a condition when we find in a grid, if there is a frequency going down, it is very necessary to disconnect the load, but disconnect the load in such a way so as to maintain the generation, as at the same time does not disturb the system. It is seen that a 500 megawatt of generation, if you go also outage, the corresponding 500 megawatt load has to be curtailed, and this has to be done in such a way so that the places where the load concentration are more are done, so as minimum effect has to be transmitted to the consumer side, as the reliability of power is a prime importance. Next. So grid discipline is enforced by the authorities as presently, and the utilities are required to and in order to do so, what has been done is for every 15-minute slot, the even all the generating units as well as the utilities are required to declare their amount of quantum of power they are supposed to consume or generate, and any deviation from this is penalized by introducing in unscheduled interchange, and the tariff at the is on availability based tariff is introduced, which is which is has a frequency as its one of its component in computing the cost. Next.
Mr. Marker, can you make it slightly brief because the system will out of
I
system.
understand because I'm hurrying you as
Yes,
hurrying
yes,
you a
yes,
bit.
yes. Please continue.
The charge of interchange unscheduled interchange is given in this slide. We can skip this. Next. In case of deviation from the utilities are penalized in terms of the load side and demand side management is to be done to affect power quality. Now need has been felt to have a device to be able to control the consumption by regulating the supply if required. How do you regulate the supply of a supply of power? That means you need a switchgear at the end, and which can be switched off from the deponent, even from the control room, and from by the utility itself in case of emergency. If you cannot do that, you cannot avoid this sort of outages. And this can be only be done by having smart switchgear. Next. The way it is why the smart switchgear may be affecting in demand management. It requires that the load management be done as per supply of the power systems power supply. Next. Thank you. I hope I have
Yeah,
not
right. Thank you. Thank you very much, Mr. Marker. I mean, we have reached at the end of the session. On behalf of Indian Chamber of Commerce, we extend the thanks to all the distinguished speakers and the delegates, and particularly for our valuable sponsors, Pascal Switchgear India Private Limited, ABB India Limited, Blastofab, and CMC Manufacturing Company Limited. Without their support, this program was not been possible. So we are extremely thankful to all those sponsors. We hope that we will get their support in our near future, because we will continue this program in the next edition. Thank you very much. Good night, everybody.